Recording in progress. Hello, can you hear me? There's no one online, right?
Yeah, we can hear you.
Okay, good. So, good morning, everyone. I think all of you are excited, right? I'm excited to see the passion in you to learn new things, new technology. Don't worry, it's not a technology. You'll not do much of a hands-on. You will do hands-on, definitely. But again, it will not trouble you in any way. So, before we start the session for today, I would actually like to revisit some of the topics that we have done yesterday, because what we learned today is connected to what we have learned yesterday. So, are you all set for it?
Yes.
Okay. Can you tell me what are the different learnings we had? What are the different types of learnings? Machine learning has 3 different types of learnings, right? What are they? Perfect. Supervised, unsupervised, and reinforcement, right? Perfect. So in supervised, again, there are 2 different types. What are they? Classification and regression. In the case of unsupervised, what we have learned was clustering. So we will limit ourselves to supervised and unsupervised for today. Okay. Now, can you tell me how do we differentiate between a supervised learning and an unsupervised learning? Yeah. Perfect. Yes. Supervised learning is where the data is labeled, where you have input data and output data. In the case of unsupervised learning, it is just the data, and by looking at the patterns, we analyze and derive insights for the benefit of our organization, whether it's a business or an NGO, whatever, right? So now, before we get into how exactly we do that, I thought we'll give a simple use case. Okay. All of you? Are you new to this school or old? I mean, have you very old? Okay. So can you tell me, if someone asks you how much time, the first day of the day you join your school, had someone asked you what is the time it takes for you to reach your school, what would you say? Yeah. Tell, that's good. Okay, 45 minutes to an hour. Was this the same answer you gave even the day you joined the school? Half an hour. Now, if someone asks you how much time it takes, you'll probably start saying a history or maybe a lecture. On a weekend, if I start from my school, from my home to school at 9 o'clock, also I'll reach my school at 25 minutes. On a weekday, if I start at 9 o'clock, it'll take me 22 minutes, 30 seconds. Probably will be so precise, right? How many days have you been in this school from? More than a year, I guess, right? Okay, whatever. I'm not worried about the number of years, but it's a long time you've been in this school, and you have traveled from your home to your school many a times, right? So all the data, the time, especially the time part I'm talking about, the time it has taken for you to travel from your home to your school, this data is implicitly registered in your mind. Do you all accept that, right? And that is the reason today, when someone asks you what is the time it takes for you to travel to your school, you would precisely, if not precisely as Google Maps, as precisely as Google Maps, but definitely precisely than the day you told it on the first day, right? Why is that? Because your brain is working, your intelligence is working. And let me tell you, artificial intelligence works in a similar fashion. Here, the data is digitized, and you don't have your brain to store the knowledge there. When you're talking with the natural intelligence, you have a brain to store the knowledge. In this case, we have our storage, computer storage, cloud storage, many things. And we have machine learning algorithms, which we apply on the data, which will produce a software. That software is called model. Okay. Now, let me go back to the same example. All of you have learned right? At least in your 8th standard, 7th standard, 8th standard. What is that? The speed is distance by time. Now, taking the same example, you know the distance, it is the distance from your home to your school. But when someone asks you what is the time it takes for you to travel to your school, do you apply the same formula? Why? Why don't you apply the same formula? It's a standard formula, it's a proved formula, and it is being taught, and it will be taught for generations also. Why do you think it is not applied? Why can't you do that? Okay. Now let's say you have. Yeah? Why do you think the speed varies? Because of various constraints. Yes. So there are various other factors also that are impacting the speed. Now, the speed, when you say the speed, it's impacting the speed, obviously it turns out that it impacts the time taken, right? Now, this is a domain which is very easy for all of you who are in Bangalore or any cosmopolitan city. Bangalore, and when your office, when your school is on the what silk board, near silk board, obviously you are a person who knows is the best than anyone else in the world, I guess. Now, yeah, please. Yeah. Now, we'll just list down the factors which will impact the speed and the time it takes for you to travel to your school. Okay. I want each of you to participate. It is not a difficult thing. It is not a magic. Don't say machine learning is a magic. If you say that, then you will not learn anything. And this is a simple example. Machine learning could be magic for you, but this is a simple example, right? The time it takes for you to reach your school. What are the factors? One is the speed. Yeah.
It's very simple exercise. So I want all of you to talk, please. It's not with two spectators here. Please talk. Tell me what is the factor.
Even the online, guys, can you hear me?
Yes, ma'am.
Yeah, perfect. Please give attributes that impact the speed.
You mentioned traffic.
Traffic, perfect. Bad weather, perfect. Yeah. Give more examples like that. Road, perfect. Vehicle, yeah. Start time. Yeah. More. Right. If there are any buildings that are under construction, right?
The purpose that you are reaching the school, maybe you have an exam or something.
Yes.
Which day you're done.
Right, day of travel. If suppose it's a festival day, and the day on a festival when there is lots of hangama on the road, definitely it will take you more time. More.
People are there in the vehicle.
Number of people. Guys, I'm explaining you how Google Maps is calculating the time. Okay, you must be thinking Google Maps is doing something great, right? I'll explain you how it. You choose and
How many traffic signals?
perfect.
We have somebody from the online mentioning accidents.
Accidents. Yeah. Do you think it also depends on the gender of the person who is driving? I think so, at least. Yeah. Sometimes some is okay for writing here. Yeah. Because we are taking all the factors possible. Only when we take all the factors possible and then calculate, our solution will be a perfect. The psychology of the driver when he's driving. Yeah. Mindset or psychology related. Yeah? Both are related. More. More.
Inspector who stops you to check your license. It will take a long time.
Yeah, what?
There's too much of traffic police there.
Police. I'll just write police. Okay. And brakes, number of brakes, does it matter?
Number of humps on tour.
Okay. And do you think it also matters based on the number of tires it has? If you're driving a four-wheeler, I'm just giving you a hint, right? Yeah. Sometimes walking is faster, right? When you're held up in a signal for 2 hours, instead of that half an hour, you can walk.
What type of road?
Yeah. Okay. Yeah.
Storage much more.
So what is the number of attributes that we have considered? 23. And we started the session at 10:02. Let's say 10:03. It is 10:30 now. In 10 minutes time, you have come up with 23 attributes. Now let's say we have a discussion like this for 2 days. What will be the number of attributes? More than 100, right? That is obvious because we all have so much of an expertise in this domain. Now, this way, whatever is the problem we are taking, we will consider all these attributes and we will take the data related to that attribute, which will calculate the speed, let's say time it takes for you to reach your school. Okay. Most importantly, in machine learning, when we are actually solving a problem in machine learning, we need to make sure that these are all the input attributes. The output attribute is, what is the output attribute? Time to reach, right? That is output. All of you there with me, right? In machine learning, please remember all these input attributes, they need to be independent of each other. Only then your solution will be precise. Now, don't you think in these attributes, there are many attributes which are related to each other? Do you think so? Right? Now, what all attributes are probably same or related to each other? Let's remove them.
Vehicle and number of tires.
Okay, vehicle and number of tires. When you say vehicle, what is that? Four-wheeler or two-wheeler? That's what you meant. Okay. In four-wheeler also probably you will have where.
If you classify the number of type of vehicle,
Okay.
then the wheels will come on.
So I'm going to remove the number of tires here. Okay. I'm just removing it. Okay. And more. Perfect.
We should not talk.
Traffic signals. Yeah. Traffic and accidents. Number of traffic signals. Type of road. Almost all of them are in a way related to each other. Don't you think so? But can I start removing all the attributes and put only one attribute? No. So what we have to do is, as a domain expert, we are all laymen, so we cannot do that. We are only giving the attribute names. If it is a guy who can actually derive what is traffic and how are traffic and bad weather related to each other, he can come up with a solution. He can say bad weather can be classified into different types of weather, right? It can be a stormy weather, it can be very sunny weather, or it can be a rainy weather, and he'll classify them. And then he will have a mathematical calculation wherein he says bad weather equal to so and so into so and so, and he gives this attribute. So end of the day, we will be left out with only some attributes. I'll not say one attribute alone, but let's say out of 23 attributes, we'll be left out with probably 10 attributes. So the reason I'm saying that the number of attributes will go down is, please remember, in machine learning problems, that in artificial intelligence problems, the data that we work on is in millions of rows. And when the data is so huge, even if you remove one attribute, which you think is nonsense, right? When two attributes are related to each other, I can just get rid of one attribute and put only one attribute. Instead of two attributes, I'll have one attribute. That saves good amount of time. And the response is more effective and more efficient and faster.
Means professor,
Yes.
we replace two attributes with one relationship.
and label it as a different attribute. Is that right?
Exactly. So when we realize that, then all the attributes are not independent, there must be some relationship with other attributes, right? We need to derive that relation and see that the number of attributes we have is minimal. Because when we find the relation, we can just derive one attribute out of the other, right? That is what we do.
Yeah.
So that is the reason in solving a data science problem or an artificial intelligence problem or a machine learning problem, it is not just the data scientist who does it. Data scientist is given the data. The data is given to data scientist. It is a domain expert who plays a pivotal role. It is also the data scientist who derives data and builds a product, but it is not just the data scientist who works on it. And you who are in the sales and marketing expertise, you have that expertise, right? You also have a good understanding of it. Though you will be actually, your expertise comes into picture after the product is done. But when you understand it, you can derive insights out of it, and you can explicitly share it with your client or a potential client to sell it. So now you understood, right? Independent data variables have to be there, and those data variables have to be minimized. How do you do that? You do it with the help of a domain expert and derive it. In this context, let me tell you a simple example. 7 years back, when we started working on machine learning, I was doing good amount of hands-on, and we were working for a pharmacovigilance client. It's a European client, though the office was here. Okay, fine. I'll say it. I was working, we were working on a project on the pharmacovigilance is where it's a little more out of thing, but anyway, I'll explain. I'll just give you a short brief of it. Pharmacovigilance is every tablet that you take will have side effects, and any medicine or tablet that you take, the side effects have to be notified to the FDA before it is actually released to the product, to the world or public. So in case there are many times the product is, let's say Covaxin or Covishield, these were done in a very immediate need, right? So probably there was not good amount of study and research done to find the side effects. But when the side effects are when the side effects are identified by public, it is mandatory for the public to inform it to the government officials in US. In India too, it is mandatory. But do we do that? No, we just share it among ourselves in our friend circle. There is a bad reaction, is negative side effect. Some tablet you have taken, what would you do? First, you'll call up your mom, your dad, your friends, say, please don't go for that medicine, right? Now, because of the social media, you'll also put it on Facebook, WhatsApp, LinkedIn, wherever. So that others also get benefit. And these text messages, studying of it and then deriving of insights from it is part of pharmacovigilance. I have raised 3 patents in this domain using machine learning text analytics. But when I'm talking about the product, which is related to pharma industry, there were 800 attributes, 800 and odd attributes, 823 or something like that. But the client has given us saying that the domain expert said, please work on these 400 attributes. I worked for just 3 months. This domain expert is there in this domain for more than 20 years. And I've used all the machine learning expertise to understand the relationship between different attributes. In spite of using 400 attributes, I'll tell you some jargon now, which you will feel like jargon, but after a while you'll understand. Accuracy. The accuracy we were getting was only 87%. Accuracy is where how accurate the results are. Okay. Now, 87, whatever said and done, we can do many trials. I'll explain it to you. But I was not sure. Then I took up the other 800 attributes, tried to understand them too, and then realized that there are 3 attributes that are missing. Then I had a discussion with the domain expert. He was okay for me to try it out. And then we tried. The accuracy jumped up from 87 or 88, max was 88 we are getting, jumped up to 93%, 6%. After that, the domain expert went back to his books and history and then realized that yes, these 3 attributes are missed out. He said that's valuable. So machine learning gives you so much of an insight. With the help of domain expert is a person who understands the domain. Let's say you're working on It can be that also, but generally domain experts are the persons who knows the industry domain very
Finance,
well.
so if you there is
Domain.
finance domain, finance.
Yeah. Now you are in, this is a farmer domain of that particular product. So he knows when the product was started, how it was started, and what are the different attributes which impact the solution. So that way machine learning. I mean, yeah, they are putting it as job title. Let's say I want to come up with an Alexa app which understands me speaking in Sanskrit and then gives. Then, do you think I can teach Alexa what is Sanskrit? I'm sure I'll not be able to. But if I have a domain expert, Sanskrit scholar, I'll bring a Sanskrit scholar. He is the domain expert. Tvam kutra gachati can be also. I'm just telling one or two sentences that I know. But tvam kutra gachati, where are you going? There must be another way of telling the same thing in Sanskrit. That I may not be able to tell. But if you bring a Sanskrit scholar, he understands. He is a domain expert. I am probably an Alexa expert, right? Or whatever. So we need domain experts wherever we go. So these are some things I want you to understand. So shall we jump into coding now? I think you're all curious to go there, right? Okay, perfect.
Want us to put this on Excel or?
No, this was just one. You will actually do hands-on on Veka. All of you have installed Veka, right? A download of Veka. All of you have, most of you are working on Windows only, right? Yeah. So I'm sharing the link of Windows, I mean, Veka download for Windows. There are multiple. The same link, just because some of you did not have it, I'm just sharing. Yeah, I've shared the link on the chat. Just download it from there, execute it. It hardly takes, it's less than a minute download and you can execute it.
Dave also is fine, right? But then I realized it's so fun. Sometimes something is put on there, you can see. Yeah, he does. He's very good. I don't know whether I will attend it. He will also put recording. Have you could install that? All of you? No, right? That link is
I have
there.
shared the link in the chat box, right?
No, but then chat they only for online.
Okay.
Can you in the chat box?
Please share it in the WhatsApp.
Just forward that WhatsApp message.
So I had to send it to Gmail. आप लोग को WhatsApp है it's there in the WhatsApp message is there.
Go to sourceforge.net projects, Veka. It is very popular. That's okay. You can do it in the short break also. Before that, we'll discuss a little more again.
You download it. Help others.
So we thought that different types of learning: supervised learning, unsupervised learning, and reinforcement learning, right?
Then we use or
In supervised learning, we have regression and classification. There are multiple types of regression. The linear regression is the simplest one. There are, but
that you can your machine. I think now
is it mine? Okay. So there are multiple regression methods, but everything is same, a little different. You can, I mean, a data scientist need to worry about it, all of it. But today we learn linear regression. In any machine learning model, these are the different steps. CRISP is termed as CRISP DM. I'll explain them. The most important is the business understanding. And why do you think business understanding is important? Why do you think business understanding is important? So only when we understand everything that we can actually come up with a project, right?
if you are in US, you will not know the value tools. So you cannot give that.
Exactly. The driverless car, which is working in San Jose in US, bring it into India, it will definitely fail. That was the example we thought about yesterday, right? Now, so business understanding and then the data understanding, because machine learning only works on data. The input to any machine learning or soft data science. Is there any issue or you don't understand anything? If so, please let me know. I'll be happy to share it with you. No, I think.
Asking questions is the key. Some of you may not ask questions, clarify.
This is going to help you get jobs. So that's the outcome, right? You're attending this program, so it will help you get jobs. So if you really want to get a good placement, these are the programs you should understand and talk. Because Mera was spending so much time, and Aloxa is spending so much time for this program. So you guys should, this is not talk, please.
See, today is Aloxa's birthday. All of you are excited about it, right?
So wishing you birthday.
Have you noticed one thing? There is a difference in the excitement. Why? Because maybe because today is Sri Ram Navami, Aloxa's birthday, or yesterday RCB has won the match, right? So, don't you think attributes are interrelated, right? Your excitement, the attribute, your excitement is related to the different happenings. So when we actually convert into digitized software, we need to exactly extract the values of it and the relation. So guys, if you have any query, please don't ask your friend who may not be also aware of it. Just ask me. I'm happy to answer any questions you have, including the online people. I think they are at least asking me questions, but you people are busy talking to each other.
I think that's not good. Please don't. Guys need to be very serious. I think we don't need external faculty to tell this, right?
Okay, so business understanding is important, data understanding is important, and data preparation. Data preparation, just now we discussed about the time it takes for you to reach your school, right? What did we say? We need to see that we will derive those dependent attributes, we will derive from one from the other. And we'll see that all the attributes are independent of other. Sometimes data understanding is what? Now you shared many attributes, right? You understood how they're impacting the data. Now, yeah, exactly. Now, let's say in the attributes that decide the time it takes for you to reach your school, if you say the number of U-turns, you understand that in India, U-turns is possible. And the number of U-turns actually impacts the traffic and in turn impacts the time it takes. So that's it. That way you say the number of U-turns. Now, if I put the same question and the answer in front of a US guy, US citizen, he would say, what is the number of U-turns and how is it going to impact the time? Because you understand the data, he doesn't understand the traffic in India. That is called data understanding. And only when you understand the data properly, you will see that all the data that is related to impacting the target variable is included in the data preparation. And then you apply the algorithm, create a model. Model is creation is the software that you create. After you create any software, what do you do? What do you do after you create and test it? That is called evaluation. Even a simple mobile app you create, what do? You test it, right? Even if you, before you enter a WhatsApp message, which you are putting to your senior or maybe your prof, it maybe if it is a friend, probably you will not reread it. But if it is a prof or someone whom you give good respect, what would you do? You would reread it. You're testing what you've written. So that is called evaluation. And then deployment. Once the software is done, what do? You have to use it for public. Public has to use it, right? So you deploy it on it. You will prepare the data only if you're on that job, and you will be given guidance by someone else to prepare this data. Now let's say yesterday we were discussing about the feedback. You may miss out something is what is. See, it is not as easy as I've shown it to you. When you're actually doing the project, the data is given by the client. The domain expert will be there. That is the reason I've showed you that example, right? There are 3 attributes, the example that I quoted, the project real project. There are 3 attributes which are impacting the target variable, but I couldn't include them on my own. I have given a clear explanation, the graphical understanding of how it is impacting. Then I had a discussion with the domain expert. Domain expert then said, let us include this. So it is a big process. Yeah, I will come to that. Let's say, to keep it very simple, let's say we have 10 rows, and in the 10 rows, 9 rows, the prediction was the right one. 1 row, the prediction is wrong. So it is 90% accurate. Yeah, that is the way validation. Yeah. See, that's the reason if you're doing a customer churn project, then if you think that there is good amount of data for one location, very huge amount of data in another location also, and they're behaving very differently. So it doesn't make any sense for you to club both of it and then create one. But when your client says you have to do only one project, you'll go back to him or her and say that, yes, that is, there are many challenges like this when we are actually doing projects. But before that, we need to understand it. So we'll come up with simple examples so that you understand it. So this is a slide on the data understanding. And for data understanding, you have many tools. Within Veka tool also, you have many ways where you'll understand data preparation, where cleaning. In the data preparation, one other important thing is, have you all filled up survey forms when you attended movies? Huh? Tell me one of you. Is there any one of you who has filled up fully correctly, 100%? Right? At least I have not done. I've never done that. But I filled up because I didn't want to upset the guy who was giving me form. So when we do that, wherever possible, what would you do? You will just put a blank, right? But when we are collecting, when we are doing a project, we need data without any blank values. Let's say a simple example where forms were given to people who have come out of the movie, some popular movie, RRR, let's say that, okay? Because I've seen the movie recently, and forms are filled up. It's not digital forms, it's a real form. You collect the forms. From the 100 forms, you create the data, and then you realize that 80% of the places there is no location mentioned, but the remaining 20% it is mentioned as Bangalore. So what would you do? What would you presume? When it is mandatory that the location has to be filled in, what would you do? In the remaining 20, 19 are Bangalore, 1 is Chennai. Let's say that. Answer. No validation here. Please answer. Perfect, right? Because that is a mode value. That is the way, even in a machine learning, what we do is we calculate the mode value, max value, mean value, and we don't just fill up the values. We will discuss with the domain expert and get an understanding saying that these are the blank values, but because our algorithm and our domain, our product requires the value in it, we are going to fill it up with a value we've calculated. In the example of the location, it is what? It is a class, it's a arbitrary value, so it doesn't have any value. But let's say the time the institute opens, many people wrote 10, some people wrote 9, some people wrote 9:30. Among the people who have written the answer, let's say 80% have written 10 o'clock. 20, the remaining 10% have written 9:30, and the other remaining 10% 9 o'clock. Now, in the blanks to be filled up, what would you say? Again, you'll go with the value 10 o'clock, or you can also take a mean of all these values, because these are numeric values. So what would you will not decide. There are two different ways of doing that. One is you will ask your domain expert saying that let me put 10 o'clock. Or the other option is I want to take a mean. From 9 o'clock to 10 o'clock, students can reach the school. Anytime is okay. So shall I go with a mean value or a max value? So the domain expert comes back with a solution, not a solution, but suggestion, what to use. That is the way we go ahead. And so we said data preparation, clean data. So wherever you think the data is not mandatory, you will remove the rows. You will also remove the columns, right? In the example where we considered the different attributes, we thought the type of road and probably the number of bricks, both are related, right? So let me remove one column. Both are directly related is what I consider. Let me remove. So that column here, that is called cleaning. That is, you are just removing the column. And constructing is where you're deriving. Yesterday, Dr. Ralok, I think you were the one who gave the example, right? Date of birth is given, but we only need the age of the person. What do you do? From the date of birth to the current date, you subtract the date of birth from the current date, get the number of days and put it as a number. That's called constructing the data. And integrating. It happens both in the data understanding phase. So as part of EDA, you have many graphs that you build. Graphs is a simple example. You visualize the data and you have a domain understanding of it and then do many things. So data understanding is part of exploratory data analysis. Exploratory data also analysis also has where you come up with derived attributes. So you have an understanding when someone says age, let me say newly born baby. What is age? She doesn't know. She or he doesn't know age, right? But if the same question is asked to us, we'll easily say, what is the current date minus the date of birth? And you come to the age.
Can you go one step? That's a situation. So,
What is initial assessment of tools and technologies should be performed. This is a scenario where you're working on the real project. Now, the data that is given to you is 10 million rows, and the number of attributes is in hundreds, or maybe let's say in thousands, 800, 900, this is possible. So I'm sure you'll not do it on your laptop. You have to do it on the cloud or maybe a GPU. So that assessment is done only in the initial phase itself. I didn't spend much time over here on this part because right now we are doing simple projects. And it is also that sometimes the data size is huge. Even in the 800 or 1000 attributes, let's say the data is in the video format. You know, videos occupy lots of space, right? So obviously your system is going to go for crash. I mean, it's going to crash. So what you're going to do is you will either take a GPU or take instance in the cloud. That assessment has to be done. And when it is an image thing, you have to go with a computer vision. And if it is a text analysis, like the pharma project we have worked on, that will be an NLP, natural language processing. I was also talking about Twitter analytics I've done, right? That is also text analytics. Yesterday we spoke about speech recognition. You saw one project, right? Where the Alexa, it's not Alexa, some other robot, which was actually translating the text. So probably it is using Google Translate API along with the speech recognition and speech formation.
With the first itself, you have to do this.
Now you have to do fraud analytics. So what is a fraud analytics? You have to do on, is it on the text or is it in the videos? You can also understand, or maybe it could be a combination of video and text also. When we're explaining use cases in the class, we'll always keep it simple. But in reality, it will be a conglomeration of multiple domains and algorithms. Yeah. Shall I go to the next slide? Yeah. Look into it. Any question there? The reason I'm not reading it because, so 80% of the time is actually gone in EDA. Yesterday you thought you learned it from the sensors, you get the data, sensors, you get the data, and then you come up with the patterns, pattern recognition. Only when the pattern recognition is there, you will actually apply the algorithms and come up with the product. Yeah, you were asking a question? Okay. Modeling is where you are actually applying the algorithms on the data and coming up with a solution software that is called modeling. Now, guys, you should be very happy that you're working on Veka. Go to a data scientist and ask him, have you seen a model? No one says yes, but you people, you will see model, because not many people know about Veka tool also. And you guys will be working on creation of models and you'll also see what it is and how it is. And then evaluation. Evaluation is, as I said, you're testing how accurate the model is. Now, let's say she said, on a weekend, ma'am, I'll travel from my home to office in 25 minutes. Now, is she saying the right answer? Ask her sister. She will validate it. Sister, or maybe a friend of hers who is a neighbor to her. And then you will deploy. Deploy is where you're all of you using Google Maps, right? How are you using? Because it is deployed on the cloud, where you can download the Google Maps and use it for your sake. AI is embedded in Google Maps. Deployment of software, not the tool. Tool is used only for us to build the product. Whereas software, once, see, now you will use Veka tool or maybe Jupyter. Jupyter is a software. I'm not touching it. Anaconda, Jupyter are the tools where we write programs in Python programming language. We don't need to deploy them. End of the day, it is only the software that you build. The pickle file is.
So, for example, Google apps, we use APIs from weather.com for knowing the weather and then writing your time will take. So that will, anyway, the Google map is what you use, not the weather.com.
So this is basically coding. Now you have a calculator. When you're using a calculator, do you know what is written at the back? Yeah. So there is a software. You would have executed .exe files to install some softwares, right? Do you know how and what is written at the back? Even Excel sheet, you write 10 numbers or maybe 200 numbers, just apply summation and you get the sum value. How is it doing? Backend, whatever you're selecting will be converted into an array of numbers. You will just add one number plus another number. So mathematical operation is done. But that is not given to you. Only when you're working on open source technologies like Python. And if you are really keen on how the projects are done, you can go to github.com, where there are many people who just submit their projects with their name. Of course, their profile is there, so they submit the projects that they have done. So even now, for that matter, the developers, most of the developers, what they do is they go to Stack Overflow, GitHub, and then they check for the answers and then they put it. Those days when we had started development, everything was like, we had to do good amount of time spending even for a small operation. Now Google search, Stack Overflow. Recently, I don't know if you have seen that WhatsApp. Even if you would have seen it, you would have thought it's not for our concern. If Stack Overflow is stopped for 1 hour, many projects will be stopped across the world. You can check that WhatsApp later. So many people see that. Yeah. So shall we directly get into the project execution now, or you want me to explain? Yeah, I'll just explain you a little because you were asking about the error. How do you identify how good is your answer, right? Now, before we actually start a project, the way we do is you are given the data by the client. Let's say, to keep it simple, I'm just saying you are given 100 rows. And in these 100 rows, again, I'm not talking about get data cleaning, data removal, data garbage removal, and I'm not talking about anything. All the data is perfectly fitted in this 100 rows. So with these 100 rows, you have to come up with a solution. Now, because you're just given these 100 rows, you'll also use these 100 rows for testing. But is it okay for you to use the same data for building the software and for testing also? No, right? It's not okay, right? Even when you're teaching a child numbers, you'll ask him some other question which you have not taught. That is the reason we split the data. Split the data such that a higher percentage of it goes in the training part and a lower percentage of the data goes in the testing part. So when there are 100 rows, let's say, to keep it simple, typically people go with 80-20. 80 rows for training the data, training the software model creation, and 20 rows for testing. So when we have got 100 rows, we use the 80 rows, apply the algorithm, and then come up with the model. Model is a software. And once this software is built, we apply the remaining 20 rows where we already know the answer. That is the target value, the time it has taken for you to reach your office. You know actual values. Now, in the remaining, let's say there are 10 attributes. One attribute is the time taken for you to reach your school, office, whatever. So you'll remove that one attribute. With the remaining 9 attributes and the 20 rows, you will apply it on the software. So you will come up with one other column, which is time predicted. So you also have actual time, right? In the 20 rows, you already have actual time. In the output that you got, the new 20 values, that is time predicted. With this, you can understand how well your software is working.
Yesterday's whatever we downloaded an app, right, for the expression of the person.
Yeah.
So you have 100 expressions,
Mm.
20 you will keep aside, and then 80 you will give it.
Yeah, it was when it was built. Yeah.
So and then this 20 you already know the answers, that somebody is angry, somebody is
Yeah.
sad.
You know that
So you
already.
that. So that you feed and see whether it's giving.
Giving or not. And when you see that it is only 60% is correct, so you're upset about it. So you'll retrain it. You'll give more data and then apply. Or we'll do hands-on. There are many attributes you can change and many algorithms are there, right? I said in the regression, we'll only work on the linear regression. But there are plenty of algorithms and many attributes which you can change. So this root mean square error is Pi is the predicted value. P for predicted, minus A is the actual, whole square divided by n, and then you take the root. That is root mean square error. The better, if it is P and A are the same, then it is very accurate. 0 is the best answer, and 1 is P is very high. And now mean absolute error is, I'll explain it to you a little more. Mean absolute is, you're not taking over the negative, you're not worried about the positive or negative, you're just taking the absolute value and then dividing by n with the number of attributes. So yeah, what is linear regression or a model? A model is nothing but an equation like this. All of you learned y equal to a plus bx, right? This formula. Have you drawn a graph? Definitely you would have done it in your 10th and 12th, right? Your multiple types of linear regression, simple, multilinear, many others. But to keep it simple, we are learning only simple linear regression. So this is the graph. These are the data points. Do you see all the circles? Yeah, these are the data points. And now when we come up with an equation to predict, let's say, this is the data points about, this is the graph or the linear regression where irrigation potential created for Rabi and total irrigation potential created. This is the relation between the irrigation created for Rabi and this is for the total. This is a linear regression graph. Now, when I go to this one particular point, I can see what is the total irrigation potential. Do you understand that? Right? It's a linear graph. But actual point, let's say this is the actual point, right?
It has got a touch.
I have not touched it at all. Okay.
Oh, it's got it.
Maybe it senses. Yeah, it is smart. It's an AI. Yeah. So these dots are there, right? For those of you online too, I know for your hand is, my hand is not visible to you, but at least please understand wherever there is a dot, it is not exactly on the line. Do you understand that? Right? It's not exactly on the line, but this is something where the error is minimal for all the points. So what is the actual value? Actual value is wherever the dot is there, or circle is there, and predicted value is the one on the red line. So what is the difference between the actual and the predicted? What do you call it? Error, right? Now, for every point, if you calculate the error, now we need to come up with an error for the solution. So what do? You can sum up all the errors, right? The reason we said mean absolute error, let us say the error over here is -1, but the error over here is +1. If we just sum up +1 and -1, the error would turn out to be, is it right? No. That is the reason we take an absolute value. Pi minus Ai mod. Mod is absolute, right? And we sum it up. The other way is you square the errors. Pi minus Ai, square it. But because you're square and sum all the errors, and because you're squaring, you need to take a square root of the summation. That's called root mean square error. So these are the metrics which decide how accurate your model is. This is an expression too mathematical. I wouldn't advise you to look into much. Just look into, but don't try to understand it, because we do this way to come up with a solution. This is again an explanation of how we come up with the coefficient. This is the way in linear regression, when you're just applying the data, it is coming up with a solution that is a straight line, right? In the case of, how is it doing? It is calculating for every point, it is calculating the error value, and it is taking the minimum value of error at every point and coming up with a solution. This is linear regression. Now, any queries before we jump into Veka? All of you, I need a yes or no, only Boolean answer. Oh, okay. Shall we take a break now? Should we take a break now or after 10 minutes? Now, huh? Okay, we'll take a break. You professors tell me. Shall we take a break now? Yeah.
No, I'm not worried about you guys because you guys are asking. I say the feedback from your so-called elders. They are saying you are not guys are less. For all of you.
Wanted to include ourselves so that you may get along with us. We also get to hear. You don't feel aliens here.
You don't park right.
Madam, just a little bit of getting them to introduce.
5 minutes. I think he helps you want for internships. All of us.
So there are a bunch of people sitting in classes, attending some classes.
So, Gary, you can introduce yourself to the team.
So my name is Gary. Quite a bit. In case you need any guidance,
They want to come to school.
don't all come together.
Go for a job.
So no, so basically getting to know your coordinates like email.
I'm also into even for girls. I love brands.
Okay.
Yeah, that's from Nagesh.
Myself, Nagesh, I work for Manipur Hospitals. All my life I've been into sales and marketing. Before joining Manipur, I used to work for scheduled heart valves, heart surgery. I used to market that. After I joined Manipur Hospital, it's been 8 years now. Manipur Hospital. Now, recently past 6 months, I am into operations also. I've done more marketing. So I here now in I work in all the 4 branches.
So we'll see if we can review have these interactions with your executive MBA teams or one of these or yes, here from industry. So don't have just a selfish agenda, sir, job here. Here are friends.
So all of you can come and teach, take a session like what allows sir.
I'm also.
Wonderful, wonderful. Which one is
Also, in fact, we also feel you're not networking enough. One day, I think one of the big we are your friends, but ऐसा मत करो. Okay, madam, and so we were just having a conversation with madam that she was a little bit concerned going at the right pace. So what is the feedback? Is it going at the right pace? Are you able to absorb? Is there anything that you want to clarify? All fine? No, because see, being seniors, they are asking more questions, so that lets us.
We don't know, actually, we don't know what.
Once you're in college, you can get more knowledge. Once you get into corporate world, you will be only stick to that particular work. So you won't get more exposure to learn other things.
Which is true, actually. When I came from industry to I was taking one set of.
The online guys are asking if the session has started. No, the session has not yet started.
So let us start the session. Sorry, madam. And thank
No,
you.
no, no, no. Thank you. So please open Veka. Even the online people, I think you downloaded Veka, right? Please open it. Please open it and click Explorer. Okay. And once you click Explorer, no, open the 3.8.6. Once you click, doesn't matter.
3.8.6.
A different version. All of you opened Veka, right? Please click the Explorer. Did you get the same screen as it is? So
Excuse
now
me,
we're going
ma'am.
to do linear regression on a data set called Boston.csv. You all downloaded it, I guess, right?
Excuse me, ma'am.
Boston.csv. It is in the Google Drive, also in the link that was shared with you. Yeah, same link, Google Drive. Volume is very low, is it? Okay. Okay, one second. Yeah. How is it now? Is it better?
Yes, ma'am. It is better now.
Yeah. Please take all the ones because you'll work on all the CSV files. To start with, we'll work on only the Boston.csv. All the CSV, download all of it. Boston, no need of Boston 1 and 2, but Boston training, Boston testing, Boston and MPG you don't need it, but direct marketing. Is it audible for the online one? Yeah, volume. Online, Daniel and Nagendran, is it audible for you now?
Ma'am, it is like very low. It's very far.
Yes, ma'am. Yes, ma'am.
I would also like to acknowledge this our friends Shashank and they are really doing an excellent job of monitoring.
Yeah. So you have many attributes like this. The reason I'm showing these attributes is we have in the model development. You remember there was a clause where we say we need to understand the data, right? In this exercise, maybe you don't need to understand the data, but these are the different attributes that are there, and all the attributes. You want me to open it? Huh? Yeah, please open it. Please open it. You have many. Please download it on your local system. See, do you have all the files downloaded like this? Yeah. please open boston.csv. No, boston.csv. Even now, is it low? The online guys?
It is better now, ma'am.
Better. They're saying it is low. Now they're saying it's better, but I have actually deactivated the list. So do you see a boston.csv in this format, right? There are many attributes here. There are 14 attributes actually. All these attributes, the CRIM, ZN, INDEX, CH, NOx, RM, age, DIS, RAD, tax, PT, B, LSAT, LSTAT are independent variables and they are the input variables. The last variable MB is there, right? This is the dependent variable. It's also termed as target variable. This is what we are going to predict. We are going to write a software that is the model where using this data, we'll apply an algorithm, the linear regression algorithm, which will help us predict MV value, provided we give these input attributes.
Have you all opened the file? Anybody is not open? Get us asked.
Yeah, because if you don't open it and I'm just speaking, then it may be a difficult task. Please make it a point that any query you have, any abstraction you have also, please open up and ask. Otherwise, you will not understand what's the next step. Did you all get it? How many attributes are there overall? Yeah. Is she right? What's your name? Is Mrudula right? Are you all in sync with her? No. What is your name? What is the query you have? You only. You said you don't know, right? Did you get it? Did you understand the name? How many attributes are there? How many columns?
14.
In this file, in the file that I opened, boston.csv.
Check whatever they're doing actually. Open up and just explain the things.
What the different attributes mean? You mean that? Yeah. Yeah. Exactly. Can you see that? Per capita crime rate. That is a, yeah, sure. With the first 13 attributes, you are going to predict the MEDV. MEDV is median value of owner occupied homes. Any of you who has a query, please let me know. Did you get it? You're, come on. You're installing Veka now? You have installed? Okay. Explorer. Explorer. Yeah. 1 second. 1 second. I'll do it. You're downloading the files, is it? No? Did you download the files? Okay, I'll give you the pen drive. You have the access to pen drive, right? You can put a pen drive.
Exactly. So you get 14 here.
That link, yeah.
What's your name?
Share the link with your friends also.
No, it's in group itself.
Okay, yeah, in the group, all of you. All the other, yeah, click that, click that. Data sets for Veka, go there. Just scroll down. CSV files is there, right? Many CSV, Boston.csv. Just download all of it. One of, yeah. No, give me the.
Just download this, all of it. Training, copy of even Boston CSV. This also is CSV file. Help them also. Could you download the files? All the files you're downloading, right? All the files, just not Boston, because every time you have to spend time. Instead, download all of them, all the CSV files.
Hi, ma'am. This is Mahesh here.
Could you download the files?
1 minute, guys, 1 minute.
Download. Any queries here? Excuse me.
Downloading that
Files.
CSV.
Online, guys, one of you had a query. What is it? Can you just
Ma'am, can you please guide us? Where are we downloading the files from?
download link? Is it? I have already put it in the chat window. Put it in the window here. That link. Copy it and paste it here in the group. Online, all of you in the online, just go to your AI workshop temp. There, it's already shared. Now we are sharing it again. What's your name? Ashok is sharing it again. Do you see that? Online, people online. Can you see that now?
Yeah, ma'am.
Okay. So go to this link and download all the CSV files. You just need to download the CSV files. Others, you don't need to. If you want, you can, but it's not needed. I have shared the link again in the WhatsApp group. What is your name? Ashok has shared the link again in the WhatsApp group. So please download it. I made him know.
So you got a group.
Oh. Did you download it? I've opened Explorer. I just need to copy all the files. See, what you have to do is when you click this, download. Now you can open this file. It is downloaded in your download folder. I just open direct marketing. What you have to do is you have to do it for every folder. We'll open your Explorer. Direct marketing, right? Download other files. Data one is there. Boston is there.
Now I have to do everything. No?
Every file, all the CSV files.
Should they open it through the software or should they keep it separately open?
Right now, keep it like this. You can open in the software also, but many people are still downloading, so you can do.
If you go to open file, select the file, open it. That's all.
I'll just go. No, don't worry. Many people are still downloading it.
Downloaded already.
Yeah. So what you have to do is go to open file and go to the location where the CSV file is.
There it is. I've saved Nagesh here.
Then you go here.
Say type file as type. No. Please come down. All files. CSV file is there. No. Go to CSV. Here you see CSV, right? CSV. No. You send those here. Did you get it? I'll explain it to you. I have realized that some of you could not download it, so I'll just show the process again. Okay. So guys, this is the link. All of you, including the ones who are online, please click the link in the drive.google.com. It will take you to a location as shown. Now, all the files are listed. In my laptop, they are listed in a list format, but in yours, it may be in a different format. Don't worry. Whichever file you want to download, just select that. And on top right, do you see my arrow? There are 3 dots, right? Please click those dots and come down to the last where you have a download button, download option, right? Please select that or click on it, and the files will be downloaded. By default on your systems, it will be downloaded in the folder called downloads. I will open my Explorer. Could you all download it? All of you, please download. Anyone there who could not download? You couldn't download? I'll show it to you. Have you all downloaded it? Whether it is shown or not? Have you all downloaded? Now, please go to your Explorer, Windows Explorer. On the left-hand side, you have something called desktop, download, documents, many folders like this, right? Click the downloads. Here you will have your CSV file. I don't have it because I moved it to a different location. Please check it if you can locate your CSV files. Yeah. No one, it doesn't, because I have shared as a CSV file, it will be a CSV file only. I mean, maybe the icon is Excel, but it must be a CSV file.
File type is CSV, the icon would be Excel.
Yeah, it is. No, that's okay. That's okay, sir. Yeah. No, don't all files. Okay. Yeah, please select all files. Boston. Yeah. Here. Open. Okay, fine. I'll just take the system. No, give me. Boston. Go to it. Yeah, no problem.
I think this is wasn't testing is the file, I think so.
This is comma separate file. Now, what you can do is, in case you have this Boston, right? You can. I'm converting it. You can say, don't worry if you don't understand it, but I'm just helping you. I'll come. I'll help. But I have given a CSV file. I don't understand why it is. But in case it is an Excel, what you can do is you can.
Ma'am, you have moved the Boston file, so it's not showing in Google Drive.
No, we are changing it to .csv.
Yeah, okay, that's good. So have you seen that? Now I've changed it to CSV.
Google Drive. Ma'am, can you move it back?
I have.
You have moved it to other place. It's not showing in the Google Drive now.
But that's okay.
No, it did not download it.
No.
I have not moved. I haven't touched the Google. This is my Explorer, Windows Explorer. I'll see. Thank you. Is it fixed for you? Huh? That's it. Now go to Explorer. You also do that. Huh? You can take yourself.
Go to file, open file. Boston, no, okay. Come down. CSV. Boston.csv. Give me the, what you can do, instead of all files, you can say only CSV file. That will be easy, right?
Yeah, exactly.
So go to Boston here.
Yeah, it came up. Boston.
Did you all get it? Okay, I don't know why it is said. Okay, what I'll do is open the Excel. No, not here. Open there. Go to your Explorer. Open the SCL. Maybe Boston. Where is Boston? This is the one. Open it. Open in Excel format. Like I will show you how to open. Or all of you have Boston training.csv. Can you open that? If you think Boston.csv is not there and it is troubling you, please open Boston training.csv. Are you all able to open Boston training.csv? I think. Okay, great. Anyone there who couldn't do that? Open, perfect. Huh? We did it, right? Okay, that's good. If you,
We are opening the Boston.csv in that Explorer.
Because I think so, I don't know how it got converted to Excel.
No, this is CSV only here.
Sure. Huh? Okay.
Open file. So here it is a CSV file, Boston. It's a CSV file.
Yeah.
In downloads. So I'm coming here. Open file. All files. No, top first one. All files. Boston is yes. Second.
Yeah, 1 second. I'll tell you. Maybe that. The problem is there are multiple downloads for this one. Have you downloaded Boston training also?
Oh, everything you're downloading.
Yeah, download Boston training, but I don't know why this icon is like this. Because
It's not opening
because
also.
open which she has put an application.
Choose another app.
Choose another app. Platform she has put. Okay, now let us say Boston.csv. Okay. I'm saving it. Let's see.
It's only about the file format, right? VPN it is not showing us.
Okay. No, don't worry.
Maybe we'll copy again. Delete this and copy it. So it should be a CSV file loss. Got it, right?
Putting it on the desktop. Naming it like Boston.
Possible data loss. Accessibility and availability. The format that is unsupported by accessibility check. Consider saving this file in the office format to enable what is the absolute no? Just say. No.
Here, it's showing as Excel actually. Okay. Bottom, you make it a CSV. Don't make it all files. Got it, huh? You? Everybody got it? Excellent. Cool. Dave. Two cheers. You got it? Got it? From all files, make it CSV. Hello.
Ma'am, this is if you have changed the file into CSV. Instead of all.
Yeah. What is your name? Answer.
The problem was all files you got CSV.
So you have a file in the Explorer and the downloads location. In my case, it is not there because I have changed it. All the people online, yeah, great. They have downloaded it. Are you able to open it in Weka, all of you? Now let's go to Weka. When I click the Explorer button, I come to this screen. You're all there with me? Yeah. Now please go to open file and we are going with the Boston CSV. I have put it in a different folder. Have you noticed files of type? You can actually filter data like this. So to keep it simple, please use .csv and go to boston.csv file. Do you all see that? Now, attention please. Any queries, let me know. Are all of you there here? You could actually import the data set over here, right? This file is called importing, opening it in Weka. So you can see all the attributes over here, right? 14 attributes. Even in the Excel sheet, we had 14 attributes. And we said that the first 13 attributes are the input data items, that is input attributes. The 14th one is the target attribute, also named as output attribute. So every attribute, please remember in any regression algorithm, all the attributes should be numeric. That is very important. So any time we get the data from the client doesn't know anything. He only gives you the data. You have some prerequisites probably. You need to see that all the data is relevant to what is actually expected. But the client doesn't know what is numeric, what is continuous, what is numeric is also termed as continuous. And discrete is where there are only possible values. If someone asks what is the gender of a person, you will say a boy or a girl. There are only two options, right? What is the day? Is it day or night? What is the time? Yeah. Sir, anything is okay. Vegetarian.
Vegetarian. So,
Anything, sir. So we have 14 attributes, right? 13 input attributes and one target value. Yeah, male, female.
So you make it 1 or 2, right?
Yeah, exactly. So that we'll learn. They are called discrete variables. Attention, please. You're not following or you're not interested. Anything is okay.
Last bench.
Let me know.
You understood what Madam told? What is discrete? It's important point. What is discrete? Anybody can say?
Can you give me examples of discrete variables?
That's why it's important to hear.
Discrete variables are only, there are multiple possible options. If someone writes, have you, asked you this question, have you passed the exam? There are only two answers. Yes or no. If the results are announced, if not, yeah, multiple answers are there. Yes or no. This is called discrete. But if someone asks, what is your height? How many possible answers are there? Multiple, right? Infinite answers. You can be 150 centimeters, you can be 150.0009 centimeters also. Infinite. That is called continuous variable. Please remember, when you are applying a regression algorithm, your attributes should be continuous. That is, they are numeric. Even the output attribute should be numeric. But in a case, as the professor was asking, in case there is an attribute which is categorical variable, like the person has passed or failed, that let's say that attribute is there. In this case, in this example that we are discussing, it is not there. But if that is there, what do? We have to convert it into numeric, like passed or failed. What do? In reality, maybe you say pass or fail, but here you'll either write 0 or 1, convert into numeric. The same thing applies when you're applying classification. They should be, the output variables should be a categorical variable. And then if you have a numeric input, what you do is you convert it to categorical. I'll show you how you go ahead doing that. It may not be 100% accurate all the time to convert it, right? So let's discuss about it later. Yeah. Yeah. Why will it calculate? I've just shown you the attributes. We have not even gone to calculation part. Don't worry. You are jumping fast. Just hold on. No, I've just shown you the attributes. Okay. Please see, you have to understand the data, right? One of the points was data acquisition and data understanding. So now the scrim data, please select it. What is the minimum value here? 0.006. Maximum value? Yeah. Mean, standard deviation. You have 4 different attributes for every data item because it's a numeric. Now go to the next point, Zn. You can see the same thing. Select that. There are different values, right? This will help you understand. I'm just scrolling through. Even the online guys, do you understand what I said? Please raise a query. I'm a little worried about you because here there is a facial understanding also.
Yes, Prof. Yeah, ma'am, we are following it.
Because I have understood the domain and I've come up with a question that MD is output. Otherwise, the client will come up because these are the attributes and you have to predict this value. It's a calculated value.
Not an input value, it's a calculated value.
It's an output value. That's called output. All the other are input values. The requirement comes from the client. He says that you have to predict MV value based on these attributes. Then you'll ask, do you have data? Yeah, I have 100. Or in this case, 506. If you do, you see this part? Yeah.
Can you give an example like if the, 506 is 5 or 6? 5 or 6 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 is 5 or 6? facial expression thing.
Yeah. I'll not give the facial expression because I'll come to the facial expression part also. Let's first discuss about the use case we discussed in the morning. What is the time taken? Time taken is the output. You're calculating the time taken, right? What are the input variables? The speed at which you're driving, the different attributes.
I am the client, I'm from
No,
DSU.
sorry,
I want
Nagesh,
to know,
Nagesh, let madam complete.
No, no, let him answer. It's fine. Yeah.
I'm from DSU and I want to know how many students are coming here exactly at 10 o'clock.
Yeah.
That is my requirement.
Yeah.
It will become the output for you to give me the data.
No. Yeah, if you want to know
I
how
want to know
predict how
students-
many,
I want
yeah,
to predict
yeah, that
how
is
many
out.
students are coming exactly at 10 o'clock.
On, yeah.
So that will become the output.
Yes, yes. So the input in this case, did you understand what is the requirement? The professor is asking how many students are coming exactly at 10 o'clock. I have to predict that. Then I say, so give me the data for the last 1 year. That is 365 days, whatever, 300 rows you have. In that 300 rows, the data you give is this student, student A, student B is coming at so and so time. So what do? I derive there from there. So you're only giving the time they're coming, but because my responsibility is to predict if they're coming on time. When you say on time, it may not be 10 o'clock exactly. It may be 10:05 also. I want to take a buffer there because generally that is the way we go. Okay? So I take plus or minus 5 minutes. And then I will create another column. I'll create a new attribute that is a derived attribute which says what is the time this person has come. Is it less than, it is more than 9:55 and less than 10:05? I'll have a calculation. There comes your programming into picture, which you're not going to do, but you will understand. No, standard deviation is different. Standard deviation is where the values is greater than, it is in between +1 and -1. Yeah, this is only a simple calculation. See, 10 o'clock is the time, exact time you're coming. But because in reality, when you're actually doing project, he's only asking how many students I have to predict, how many students will come on time. When it is on time, if you have to go precisely 10, it may be that a guy who comes at 10:01 is not coming on time. We don't want to have that buffer. We need to have a buffer. Yeah, I'm creating because I think this client of mine is okay with it. And I wanted to give you this excuse. Yeah. Otherwise, when you say precisely, I only want 10 o'clock, I would only go with the 10.
Or if the client requirement is from 10 to 10:10, then you will have.
Yes, client is the God for us because he is giving us the requirement. So now the client said on time. He didn't know. I mean, he just said, I want on time. Then you, because you are understanding how the machine learning works, you go back to him and say, you said on time. So even if a person comes at 10:01, we are considering him as delayed. Is that okay? The client is generous. He says, no. Let us have a buffer time.
This example, the last value MP will be the output would be 10.
Yeah. Yeah, output is MB, which we are going to predict. In this case, 10, like that time. Did you all get it? Yeah. Okay, so please go through each variable. We have to do an understanding of the data, right? Yeah, I'll explain it to you, but just scroll through it because this is the first example. I want to spend more time on it. When we go to classification and clustering, we may not spend so much time. But each attribute, if you go through the values on the right top, they are changing minimum, maximum, mean, and standard deviation. At the same time, the bottom graph, bottom right, you see a graph. This graph only shows the values. That is the graphical, it's called a bar graph. Histogram, also called as a histogram. Yeah. Which shows how many values are there in this particular range. Row or column? That particular attribute you're saying. Yeah. Or not row, it's a column, it's attribute, column. This CRM is an attribute. Set of rows. Yeah, okay, whatever, yeah. Yes. Yes, only for that particular attribute, whichever you have selected, it is showing.
I think we have to change our languages. Like row, column. So where we saying attribute. Got my point?
See, each column is an attribute. Crim is an attribute, which is a column. Okay. Every column has how many rows? 506. 506. If you if you go here, do you see the relation is Boston? You're all seeing the Veka Explorer, right? Relation is the data set name. Name is termed as relation over here. And instances is the number of rows. How many? What is the number of instances? Somewhere in the back, one of you, can you tell me what is the number of instances? I think you have opened Boston training, I think, right? You should open Boston CSV. CSV. You have opened a different data set. So
good example is the age actually, where minimum age and maximum age you can see 2.6 is the age.
Maximum. Now, what we are going to do is, now please go to classify. Do you see the classify tab? Go to classify, and after pre-process, you have something called a classify tab. Yeah. Boston only, but in the pre-process, you have all the attributes. When you scroll through attributes, you see the minimum value, maximum value, mean, and standard deviation. Also, you see the graph. You can see there, the top right and the bottom right. Okay. Just scroll through different attributes, you see the values like this. The reason I'm saying you have to do this is because you have to understand the data. In this case, we are not doing anything, but in a case where the speed of the vehicle, let's say, in India, we have a regulation that the speed maximum should be, what is the maximum? 80 kilometers. But okay, on a highway. Now, let's say someone is driving at 350 kilometers. You have that data also. You are trying to predict about the accidents, right? Now you see a guy is driving at 10 kilometers, maybe 20 kilometers, to keep it simple, extreme value someday. And someone is driving at the data you got is 1000 kilometers per hour. Don't you think? Hello. Hello. Is it better now?
Yeah, ma'am.
Is it better? Is it better?
Hello. Hello. Mahesh, are you there?
Yeah, it is working.
Let us say
We
there
can
is
hear the sound.
a speed which says it is 1000 kilometers per hour, and the number of rows that are there in your data set is 400 rows. Do you think you'll have patience to go through let's not say 400, it's 40,000 rows. Do you have patience to go through all the 40,000 rows? What would you do? You will just scroll through this. This is a very processed data set, so you don't find any anomalies. Let's say here you have one graph which is going on top. There is another point which is very minimally seen. So there is some anomaly over there, right? Anomaly, you remember anomaly detection yesterday? So in the data, you have an anomaly. So what would you do? Immediately, you look into the data set, understand where all anomalies are there, you'll report it to the domain expert or the client, who will come back saying that, yes, whatever, wherever there is an anomaly like this, keep an average value, maybe 80 kilometers, whatever. So that is the reason we need all these things. The reason I'm not going into deep is you will not experience any scenario like this, but a data scientist will definitely come up with this. So Alok sir, this is for you. You can just scroll through and you will see the data. Okay. Yeah, go to classify, because now you understood the data set, right? You got the data set, you have done a data understanding also. Now you are going to model. So what you do is you go to classify and choose. Choose is where you choose the algorithm. When you go to choose, go to classify after the pre-process.
On the top menu bar.
Here, do you see my arrow here?
Top left corner.
please select functions, and you have something called linear regression there. Do you also? Yes, second one. Yeah. Please don't jump. All of us, all others should understand. What is the target variable? The output variable? Mic is not working. I'll come there. Choose, please select functions. The reason it is not highlighted is
the problem is you selected cross validation, use training data set, and
Everybody could open that arrow that pull it down. You will get
here you see linear regression. I'll tell you.
all of you, can you come till here? Could you come till here? Linear regression, right? Now we are selecting this. Please see, it is not supply test set, use train set. Select that. I'll explain you what other parts are, okay? Now, all of you, please, did you do this part? Anyone who couldn't do that? What is your name? Excuse me, is your name? Anu, did you do this, Anu? So please click this option, linear regression. After the choose, you have a linear regression, right? Once you select it, just double click that. I am again doing that. Even the online guys, just single click is also fine, not double click, but single click.
But we have to select use training set.
Use training set. You can select other options also, but right now just select use training. So do you all see these options there? Can you see this? Could you see that? Now, do you remember I was talking about a scenario where the accuracy is just yeah. So do you remember I was telling you about a project where the accuracy, whatever I did, the accuracy is from 87 to 88. What does that whatever mean? Whatever means there are many attributes in every algorithm. There are plenty of attributes. Okay? Now, those plenty of attributes are nothing but these. Do you see these attributes? The batch size is 100. M5 method is one of the methods in regression. You don't need to worry about it right now. But if I change this M5 method to something else, it is possible that my accuracy will be increased. It is also possible that batch size, instead of it being 100, I can increase it. Debug is false when you're developing because you want to debug it. Debugging is where you are fixing the errors. Yeah. All these attributes are like this. Yeah, please. Boston. See, Boston CSV is used for creating the model. How do we do that? I have explained you, right? When you're creating a model, you also need to test it, right? In that case, what we do is we split the data set into train data set and test data set, right? So let me complete. I'll just take 5 minutes of time, then you can come up. No issues, no issues. But in this case, I've given you Boston.csv. So we are just creating a model. That is the reason I said use training data set. And using the Boston.csv, in a minute's time, you'll create a model. I'll show it to you how it is. And supplying data set and cross validation and percentage split, I'll just explain it to you. First, hold on for a minute. Then say, okay, you come to this screen, right? Let everything be default. Don't worry about changing the values over here. Just say okay. And then make it a point that here you select MV is the target variable. In any case, if you have not chosen this, please change it to MV because this is the variable which you are presenting. Scroll down.
Next, more options.
Here. Okay, good. If it is in MV, that's fine. In case it's not there, change it to MV.
Number empty.
Then you say start. Hey, you've created a model. And the model is nothing but this. Do you see the model? I have selected it on the screen, but you can see it on your system also. Do you all think it is in a similar fashion as y equal to ax plus b or mx plus c, right? Now, as the professor is asking, now, why is that it is minus 0.1084 into crim, right? And plus 0.0458 into Zn. There are many values. These are called weights. These are weights. When we are calculating y equal to mx plus c, in the case of speed and the distance traveled, definitely speed is directly related to the distance traveled. But in this case, when it is minus, it says that crim value is negatively related to mv. So as the crim value is going up, our mv value is going down. As Zn value is going up, mv value is also going up, but it is not straightly going up. That is, the relation is not 1, but it is 0.04. These are called weights. And then there is a constant called 36.3411. Now, this is what I said. Go to a data scientist who has not worked on Veka. Have you seen a model? He says no. How come? Hey, come on, we can't see a model is what they say. They may bluntly argue with you also, but you can be as blunt as them saying that I have checked. Come to Veka. When they look at Veka, probably they'll accept it. The positive no.
The positive outcome. And the more the positive value, then it is.
Yeah, okay. Your name? Murdula. Murdula has a query over here. How is MV equal to minus? I'm just taking crim value, okay, for you to understand. Minus 0.0184 into crim. How is MV related to crim value? So when we say minus, it only says that it is negatively related. Like, let's say I am taking a class for 10 minutes. You're happy about it. If I take for 1 hour, you'll be happy about it. But if I take it for 7 hours continuously, you will be definitely be unhappy. It is related negative. That is called negative. Like let's say the weight of a vehicle you're driving. The higher the weight, again, this is not the right example. Yeah, speed is directly related. The more the speed. No, but again, no. Let me tell you something. Yeah. The way an object, if you take a feather, then you say, "Look, it will fly faster." The same speed, if you take a mobile and then you try to fit, you can't fly it. The higher the weight, the lesser it flies. It is negatively impacted. The higher the weight. Yes. I'll give you another example. The more money you earn, Professor, there is some.
Professor, we are hearing some noises in between.
Yeah. Is it better now, Nagendran? Is it better? Hello, is it better?
Now it's fine, Professor. But in between there are some
fine. Yeah. So let's take the salary earned and the amount spent. A guy, I'm not talking about misers and no mentality coming into picture over here, but generally by default, if you earn 10 rupees, you'll probably be ready to spend 5 rupees. But if you earn 100 rupees, you'll spend more, right? That is directly proportional. Indirectly proportional is higher the weight, the lesser it flies. Like that. Okay. Now yeah. Okay. There's some. Okay. Fine. Yeah. So now let's go to pre-process, and because there's something called visualize all, I missed out telling you. There is a button called visualize all. Do you see this here? Please go to pre-processes. The tag.
Ma'am, this is Mahesh here.
Yeah.
Could we please go to the classify tab one more time?
Yeah.
And in the summary, I see different values than what you see on the screen.
Yeah, no issues. The reason you see different values is probably you have changed any attribute values over there,
Nothing. No
or maybe
changes.
the data set that you have chosen.
The MV dataset is all similar values, but the summary is different.
No,
My
no.
summary
Is it a similar value or the same value? There's a difference between similar and same.
Same values.
Pakka? I mean, are you sure?
Yes.
Yeah. How about this?
Same. Same. I have M5 100 false, false, true, false, 4 false, 1.0 E minus 8 false.
Yeah,
And all the
that's what
values
he
are same.
says. The coefficient values are different.
Yeah. And
That's what I'm thinking. Maybe he has taken a different CSV file.
No, the same CSV file, Boston. I converted it to CSV. I had
Okay,
XLS.
let's come to that point, but this is very much possible. No, there's no issue. See, it happens like that, but when all the input attributes like this are same, generally it doesn't happen, but we will discuss about it a little later.
Sure.
Who is this? Yeah,
sure. This is
that's
my
what I'm saying. So do you see correlation coefficient, mean absolute error, root mean square error? These are the error values we are always worried about. Generally, we go with the mean absolute error, 3.272. You remember, sir was asking about accuracy. How do you calculate accuracy? So these are the different measures, metrics we call it. Yeah. Generally, in the case of linear regression, we either go with mean absolute error or RMSE. Okay.
Right.
Yes.
Just for the
When you are programming using Python, even there after you apply the you apply linear regression, you get a model, and then you have different functions to extract these values. Here, because you're using Veka, everything is given to you. That I'll come to you later because I've taken only Boston CSV. Yeah. So this is the way you have created.
Ma'am, just for the reference of put what I see in the WhatsApp group. AI.
Okay, fine. Now let's go to pre-process. Please select visualize all. Visualize all, we need to do it immediately after we import the data set. I just missed it. When you say visualize all, you see the complete data set. Instead of you scrolling like that, all the attributes in a single attempt, you can see how they are. Good. Next to classify, you have, right? Did you get it? All of you got it? Yeah. Go to just see my screen. There is a classify button, right? On top tab, classify tab is there. Next to that is pre-process tab. Now just check the screen. Please check the screen. Come down and on the right side, you have a visualize all where my arrow is moving. Even the guys online, did you get it?
Yes, ma'am.
Yes.
Hello, online, anyone?
Yep.
Is there any query there?
No.
So did you all get it? Visualize. You could all
Yes.
see that, right? Now
Yes.
let us go back to classify again. Initially we use training set, right? You need not close it. Just be there. No issues. Yeah. Now what we'll do is we'll go to pre-process again. Now say choose file and take. No, not choose file. Open file. Open file. Go to Boston training CSV.
Professor, just one question.
Yeah, Boston underscore training. Do you see the instances here? It is 417. Yeah, you see similar data, but the only thing is number of instances is less. That is the number of data points.
Professor, I have a question. So
yeah, please go ahead.
So here we wanted to calculate MV, right? So MV is our regression Y. So but we also have some data fed in for that. So is that how it works, or because we only wanted the X values, right? So why
using the data, we are actually creating a model. That is the function, right? See, when you're doing something, we are not teaching how to do it. It's not like reciting song. In this case, how are we teaching in machine learning? From the data, the model is built. So initially, when we are giving the model, what we do is we give the data. So from this data, the model is built, like here.
Yeah, so it is
How do
here
we
is
build
the
this?
reference.
Only when everything is there.
Okay.
Once after this is built, when you're testing, you will remove MV. Here MV is already there. You remember sometime back I was saying this model helps us predict this. With this
That-
equation you can predict, but you already have actual also. Now the difference between the actual and the predicted is the error. That is what is shown over here.
Yeah, so for
Now in future, let's say you have this model and your client comes up, please calculate MV value. Please predict MV value. I'll give you the values of CRIM, ZN, CHAS, NOx, RM, whatever, all these input attributes. So what would you do? You apply this model, give all these input attributes, and then MV is created.
understood, Professor. So it initially needs the output variable, how it behaved also for a learning purpose. Understood.
Yes. If you think they're related, see now, let's say you're learning, there is no relation between age and, I mean, if he says he wants you to find it out, you can find it out and say that there's not much of a relation between the input data items and output data items. But because there is not much of a relation, the accuracy you get is very less. Yes, you have to ask him relevant data. Now he gives you the data about the traffic, and now he says, you tell me how good are the people who are driving at steadies. Do you think you can relate it? No, it is completely irrelevant. So, but you will try to find out some solution and then probably give it to him and ask him more details. Yes, perfect. Now, if you go to visualize tab over here, all of you again, there is another tab called visualize. Do you see MV? Is it related to CRIM? On top, after pre-process, you have classify, right? And then cluster, associate, select attributes, and visualize. So now from this, MV, is MV related to ZN? It is very related to RM, right? Age also to some extent, but when you see ZN and CRIM, there's not much of a relation. CRIM at least, do you see it is falling down? That is the reason you get a negative minus value.
Professor, does that mean we need to edit or wrangle with this CRIM data or see what went wrong?
No, you should never ever edit data. The data given to you can never be edited. If you edit it, you are violating the ethics. You're only understanding how the data is. Now, let us say ZN you think is not related to the output, you'll remove. Yeah.
Okay.
Cleansing the data. If you think, see from this, oh, got it. Yeah. So if you think ZN is not related, in this case, I just kept it because I wanted you to understand it. But in a real scenario where you have hundreds of attributes which are related and you think one attribute is senseless, what you would do, you think it is not needed, but you will not take a decision. You'll go back to the client will in turn go back to the domain expert, and then they come back.
But here, Professor,
example, let's say you have taken the data of people who watched a movie, you have taken their feedback. There is an attribute called serial number. Do you think serial number really matters? Not, right? That's the way. So but sometimes it happens that the guys whom you surveyed initially, probably the guys who took the forms, they were very patient enough. So the first serial numbers were positive feedback. We don't know. We cannot come to a conclusion just by the meaning. We need to do an analysis like this. And then when we say that first 100 serial numbers, the output was positive. Later point of time, why is it negative? Then you'll go back to the domain expert. Domain expert knows. The guys who go for taking the feedback form, initially they'll be very patient. So probably it is like this. So let us retain this. Just giving you an example.
So this sheet we should use to also see for interrelation between attributes.
Can you be a little loud? I am unable to.
So we should we use this sheet to understand the interrelation between the other attributes also? And
yes. Only for understanding. This is just for understanding. If you scroll down, You can see that all the attributes are there. Yes, exactly. Even on Excel sheet, we can do all this. But the only thing is, even in Excel sheet, regression and classification, they've come up in only in the advanced Excel that is there now. Algorithms. But again, for you to understand, this is more user friendly and understand. Yes, yes. Because this is developed for building machine learning algorithm. Yeah. Mhm. Yeah. Mm. Mhm. You will not define it. Go to the see, go here. What is that you're asking? Age, right? Age, this guy has understood that it is not relevant to age, and that's the reason age is not at all included. Yes, it is not related. It is not relevant. Yes. No issues. Yes. But remember, these are all only for your insights, and these insights you have to share with the client. He is the judge, whatever you do, but you need to have the proof whether whatever you're doing is okay or not. Are you all there? Now, shall we go to the next point? Yeah. Perfect. Yeah. Yeah. Now, we said use training data set, right? Now, let us go with the same use training data set, but instead of using Boston, I want you to use Boston training. Open file. Proper from the beginning. Go to open file. Just go to Boston _ go to pre-process. There is open file button there. Go to Boston _ training CSV. Here you see there are only 417 rows, right? Attributes same, because we are taking the same data set. The only thing I've done is I have split the data into train and test at random. I haven't taken, please remember, when you're doing, you have to do at random. It's not that the first 80% rows you will take as training data set. You need to do it randomly. Now you'll go back to classify button and do the same thing. Start button. So you got a different model built, right? Now go to supplied test set. Are you all there? Please go to supplied test set and set open file. Now you're going to Boston testing CSV. So this data set you are using to validate how accurate our model is. No, I'll come here. Go to classify. At first you said use training set. Now go to huh? What is not to
Boston training,
Hmm.
and then we said on open.
Open.
So now what I have to do?
Now go to classify.
Okay.
No, you don't have Boston testing. There is another file called Boston testing. There are two files, Boston training and Boston testing. Yeah. Testing. Testing. Close it now. Yeah. Now say start. Got it? Training, at first you have to take training. With that, you are creating a model. And you know, I said it, after you create the model, you have to test it. Initially, I just showed you how to create a model. Now, using the training, you're training it. Now, how do you test? Go to the second option there, supply test set. Select that. When I say set, I can select the test set and then run it. Then I'll get the output. You get it? Did you all get it? You?
Open file. Test is there, right? Open. Yeah, close it. Now set start. Start button. Now this is what is needed. Yes, it's comparing, it's validating, evaluating it. This data. See now, the first one you did it is here. The second one is here. The second one, yeah, time also. As long as you put your weka, it will be saved. If you want to save it, again you copy it and save it. Did you get it? After that, close the button. Close it and go to start. Start, yeah. So with the training data set, you created a model. You have specified what is the test data set. So using the test data set, you're validating how accurate it is. This is
I have another doubt. We are instead of using some different attributes. We can use other different attributes.
Yes, you can.
Like example, morning we took like that creating some of aerial data.
You can
Like
use
the example
any
of
attribute. In this example, I've taken Boston. It can be any attribute.
Customer will give you that. What attribute?
Or you know what?
There was different meaning over there, like
Yeah. No issue. See, when you're working on IoT data, even the customer doesn't know what it is. He says Act 1, Act 2, Act 82, 82, 82. So there again, you will have a discussion with the domain expert. Domain expert also doesn't know anything over there, IoT analyst. So you will come back and say, this is related to speed. So instead of putting 82, 32, I'll say speed attribute. You as a data scientist, you'll understand what it is. So there, understanding plays an important role in IoT. There are many. Did you both get it?
Yes.
Yeah, all of you. You got it? Did you get it? Yeah. Please close it now.
So we close. Now we close that.
And then press start button. Start. You have supplied the training data set already, right? Did you do that? Okay. Did you get it? Using the training data set, you have created the model. Now you have supplied the test data set to test how it is. That is the reason you get the error. Whatever. Did you get it? You've set the test data set and then run also, right? And let me tell you now your test set the test data set, right? Did you do that? Yeah, you did it. After that, you will say start again. Oh, this is the one, is it? You have set the data set? Yeah. Okay. Using the training data set, the model is built. Remember, we said we need to evaluate. Whatever you do, you have to test it. For testing, you're taking this. Both Boston training and Boston testing are taken from the Boston CSV file only. So all of you, I want to tell you one small thing. You have worked on Boston CSV file, right? Where 507 data points are there. That data set is split into training data set and test data set. So all the rows, both training and testing, Boston training and Boston testing, when put together, will make Boston CSV file. Yeah. It's a linear regression model. Yeah. Error, mean absolute error. You remember I said, right? What is the difference between, yeah. Yeah, because training, you are training. The first one when you are, it's like this. You have a small sister, let's say. You taught her 1 to 10 and ask her the same numbers. She'll tell you better, right? Instead of you asking her 25, right? 25, you'll ask her 5. She'll do it better because she has already learned 1 to 5. I told you, right? You go here. It is not possible to reduce the error unless until the data is good and huge. But the other ways of changing the error is change these values, these attributes. There are many, you need not get into you being in this profession, but as a data scientist, there are many things that they can do, change the value. More data should be more and it should be relevant also. You cannot get some traffic data and give it to this guy. Some Indian traffic data and you give it to this guy. The data size will be more, but it should be relevant, right? That's it. No, did you do this? Huh? You did, and you said start also. Okay, so no query. Huh? Got it? Okay, you have to set it. Go to set. Set. Yeah, now you have set it, right? Close it and go to start button. Yeah. So with the training, Boston training, you created a model. And once you created the model, you're testing with the Boston testing. You have, yeah. You had Boston's Excel listed CSV file that all the data was there. I have just shown you that data set, which has 13 input attributes and one output attribute, which is MV attribute, right? Now, what I've done is I've split that data set into Boston training and Boston testing. With the Boston training data set, where MV value is already there, we are creating a model. Now, we take the Boston testing data set and we also specify what is the target MV, which we have to predict, right? And when we say test it, what it does internally is this attribute is there, right? MV, it will remove that. And you have a model. With that, it will predict these 13 attributes, it will give us an input. So you will get MV predicted for the 157 rows. And then this predicted value will be compared with the actual values, which you already have. And we'll see what is the difference and then give an error. Did you get it? I'll tell you. Yeah. Set, and we are applying the set test. Please select set. Yeah. And you go to open file and select the Boston testing. Yeah. And then close it. This is basically your training, you're creating. Yeah, start. Yeah. So with the training data set, you're creating the model. But for you to evaluate, you need to have the original values also, right? So in the Boston testing data set, you're testing it. And that's the reason you're getting this. The original file you're testing it also. Yeah. Hmm?
We also get the R square value.
Yeah, yeah.
So here, Rekha is giving that.
It's giving, right? Correlation coefficient, mean absolute error, RMSE. Yeah. Relative absolute error. R square is not given in Vega. Yeah, it's not there. But we can get it from these values. We can get it. I have not delved deep into it, but we can get all these values from the. We have a relation also. So, guys, I want all of you are done. You people, I didn't come to you. So let's go back to the Excel. This is the Boston CSV file. Yeah. Huh? Ask me. Rules, sir. What is error you're getting? What is it you're getting? Rules. At first, open your CSV files. Where are they? Open your CSV files, Boston CSV. No, CSV files. Go to your Explorer, Windows Explorer, and the file system. Yeah, open your CSV files. Where is Boston testing? Training only you have. You don't have testing, no? Training is there. Testing is not there, right? Okay. Now go back. Close Veka. Open it again. Let's see. All Veka instances. You have plenty of Veka instances. Close it. Sometimes it happens that you have when you have multiple Veka instances open, it will get confused. That is also there. So please keep your system clean when you are programming. Did you close everything? All of it, close it. Yeah, close it. Yeah, close this also. Okay, open.
Yeah, sometimes you better close and open it also.
Yeah.
Might help.
Now go to open file. Yeah. What is this? Boston? Boston. No, don't worry about Boston. No. Go to classify. Anyway, do it. Classify. Go to choose. Use training data set. This is MV, right? Now you are saying start. I think I've already pressed start there. So what you do now is go to, again go to our, because initially we did Boston, right? Let's do Boston training. Go to Boston training. Go to classify. Go to test. Yeah. Go to test. Boston testing. Yeah. Close. Okay. And now close it and say start. You? Did you get it? Okay. First go to, can you help me? But if you don't get it, ask me. That should be fine too. Anyway, I've come here. That's okay. Good. Set. Now go choose linear regression. Hmm. Hmm. They will not get any information. It is you who will get information. For them, you will not give all these things. What they want is they want a product, they want a model where they'll give all those input variables. Now you have to predict. How do you do that? You got this model. So you will ask them input variables. Give me all input variables, then I'll tell you what will be MV value. How would you do that? Because you have this equation, you will supply all the input variables, you get output. You will just give them the output. You cannot show them all these things. You don't need to also. But they don't want, they only want, they're lazy bugs here. Why do they worry about all programming? Let me finish this, then I can come to other examples. See, many people are. I'll tell you. I'll tell you. Let me finish this. At first, people have to understand it, right? Some people are very fast. Some people are easy. Got it? Huh?
To help your other teammates to get it done.
The problem is, I think Boston, this one, huh? No, no, don't take this. Boston, this is not a CSV, it is .csv file. It is still an XLS file. It is fine, but it doesn't open. So what you have to do is go to your Explorer. Where is this? So what you do is, oh, sorry. I'm just closing all the Excels wherever the Excel. Now what you do is go here.
Anybody who's not got, just let us know.
Save as, right? Do you have .csv? CSV, comma, this one, CSV MS DOS. Huh? You remember yours is DOS, right? I mean, yours is a normal system, not Mac. If it is Mac, you have to put, yeah, if it is Windows. So you put this. Now you say save. Now open it. 1 second. Just close this. Just close this. See your system not your system, but generally in any system, close whatever. Not like that. To keep it better, you whatever files you don't want to use it, just close them. That's the reason I was saying whatever you don't want. Now go to Veka. In case you don't get any, I mean, you don't get anticipated output, you call me. All online. Can you hear me? And could you do that?
Yeah, ma'am, we are.
Okay, fine.
Yes, ma'am.
So just to reiterate what we have done, Boston.csv file has all the data, 506 data items. That's also termed as rows. This was taken to create a model. That is just creation of model. Now, the same data set I have split into two data sets, right? Boston training and Boston testing. The training data set, Boston, when I say training data set, it is nothing but Boston underscore training data set. That data set has more rows. If you have noticed, it has 70 to 80% of the rows. That is used to create the model, because in reality, when we are doing a project, we do it like this. That is the reason I have done two steps. One is simple model creation. The next part is how are you evaluating. When you are evaluating, you take the original data set, split into train data set and test data set. Random, yeah. No, both the sets, yeah. It will not be repeated also. Random, at random, I have split it. Personally, I have split it, but programmatically, when a programmer is doing, there are ways where you can split it. So using Boston training data set, you're gone to Veka, right? You used training set, you loaded it, and then supply test data set and use set, supply that, and then set start. This will give you the result. Mean, absolute error. Based on these errors, you will decide how accurate is your model. And of course, in a client requirement, as I said, there will be a requirement that accuracy should be so and so. But in most of the cases, the clients do not know what is machine learning. Now they know a little, but then you will go back and say the error is like this. And for you to minimize the error, what you're doing, you will double click it, and there are many values over here, right? You see M5 method is there, greedy method is there, no attribute selection. Don't go for no attribute, greedy method is there. You can go to one of the methods when you have time, when time permits, and see how the error is error value going down or going up. If the error value is going down, it is better for you, right? Better for you and the
How
client.
to get to the screen? Veka generic object editor.
Go here, you have choose, right? There you just give us click, left click. You're creating a new model, right? When you're creating a method. The if it is 0, it's absolutely correct, right? There is no error, mean absolute error. The client. We always go with the minimum possible errors by trying the different ways, especially when we are doing the POC. Before the client approves, we all, especially in a new technology like this, they don't know anything. But when it's a new technology like this, we need to do a POC. POC is proof of concept. Proof of concept. So you come up with a solution and share it with them. Also say that the possible error values are like this. So they do an R&D. They have internal team to decide. See, there is also something called cross validation. Do you want to learn a little more? Then if you are in a hurry, we can wind up. But yeah, great. So cross validation. This is done when you have only the training data set. You don't have any like Boston.csv, right? Where I want you to go to pre-process again. Please open file. Go to Boston.csv. No, it's open. Go to open file, select Boston.csv, and go to classify, then select cross validation and select the folds as 10. I have chosen 10. I'll explain you why it is like that. Okay. We'll just do this, apply the algorithm, then I'll explain you what is behind. Okay, we'll redo it also. You just selected cross validation, you have selected folds equal to 10. I'm taking the number 10 because it is easier for us, anyone to understand and remember, and then say start. See, if you notice, the error value would have gone down here. Now let's go. I'll explain you what is cross validation. Guys, whoever is online, I want you to be a little proactive. I cannot be asking you again and again. Yeah. Here I see the faces. If they're a little doubtful, I ask them, but those of you who are online, I have opened MS Paint for me to explain it to you, just for me to explain it to you. Okay, I'll open Excel sheet, that is probably better. Yeah, online, if you have a query, please unmute yourself and ask, but till you have a query, don't unmute yourself. I think there is a disturbance. Is it one of you? Nagendran. Okay, fine. So let us say I'm just saying this is the, I have selected 10 cells. Every cell has 10 rows. Imagine like that. Okay. Now, when I say cross validation 10 folds, that means that 90, that is 9 folds will get into training data set and the other fold will get into test data set and it will create a model. Now, the second time what it does, it takes other 9 folds. Resound somewhere. So let us say the first time it takes these 9 for creating the model and the 10th fold for testing. The second time what it does, it takes these 9 folds to create the model and tests using the first one. The third time what it does, it goes like this.
Oh, it skips 1, 1, 1 and then takes
Yeah.
the other.
Yeah.
So same data using for testing.
Same data, but different times. The time when the data is part of training set, it will not be in the testing set.
Different iteration it's using.
Yeah, so this way it is multiple iterations, 10 iterations are there, right? So many times it is tested, and you know, right, when you test multiple times, accuracy is better. That is the reason you got a better accuracy. Hmm?
506 attributes. Then I can give 506.
Perfect, you are perfect. But when 568th data item is given by the client, here you say you got 100% accuracy, and there you'll fail. That is called overfitting. And as a data scientist, you should never overfit the data, because you're overfitting your model only for this data. It has to work realistically also, right? Right.
And whenever when the data is now we are doing for 506 and the client comes back and gives another
New
100
data.
more. So that
It will fail. Here, how can you claim it that is? Yeah. The model is working only on this data. It is working so much that it has to fit into this data. Yeah, yeah.
So it's just like cropping the data.
Not, you can't use the word cropping. You can't use the word. Yeah. See, in case we come up with a linear regression model, which is not a straight line, instead we can draw a line like this also, right? Probably like this, and then come up this way, right? That time it will be fit, perfectly fit. But when a value comes between these two, or maybe these two, probably this is more accurate. These two, it will definitely go false. That is the reason overfitting has to be avoided at any time. I'll give you a simple example. How many of you have tried Google Translate? The first time you have tried? When was the first time you have tried? Just approximate. No, no, I don't want when. But when was this? Was this 10 years back?
5 years back.
Okay.
So the customer was there, she saw the letter and told it.
Good.
Now you try the same. Definitely accuracy. will- So that is a classic. Now the training, it has been trained better. The time when they have they've created Google Translate. I'll give you my example. I used Google Translate 16 years back. It was just open and then I wanted to try. And then I tried English. I tried Hindi, Telugu. You know what? It was all giving me rubbish. I said, I'll not use it. No. When did you try it? Before me or after me is a question. I tried it 16 years back when my baby was an infant. I said I will not. Then I said I'm not going to try it. I don't know. Then back then I didn't know what is machine learning. But now I tell you, it has improved quite a bit. My daughter has written a Telugu essay for some context. She doesn't know Telugu writing. She knows to little extent, but she has used Google Translate. And we are there to validate. We are there to translate and test, to test it. Yeah, she wrote all her thoughts in English. She knows speaking Telugu. I'm giving you a live example, guys, only for you to understand, nothing to share my personal experiences. Hmm. Yes, because it has been trained. And all of you are using Gmail, right? For those of you who are using Gmail from decades together, initially there was only an inbox, right? But now you have social media, you have, yes, because it is predicting, like the way linear regression is predicting. We'll go to classification example after the lunch. Then in classification, it is predefined values. Like in your Gmail, you have genuine mails, which will drop in genuine, that is inbox, which are trash. What is that folder called? Spam, which are spam. Like one of you was giving example, right? You will become a billionaire. That is all spam. Wherever money is written, you will become. How happy are you? Yes, that is a way. That is a giving a feedback. Yesterday I was telling you that. No, that is called classification. We'll do that example later. So we have three predefined values in Gmail. Genuine mail will fall down in inbox. Spam, whichever you think is you becoming a billionaire, that will go into spam. And social media. Social media is easy, right? All of you at the back, are you interested in what I'm saying? Great. Facebook, LinkedIn, Twitter, all this fall in the social media. And the updates which we get, that will fall into update. I don't have update folder. Where is it? Percentage split is where, let's go back to Veka. Good, I'm happy you're asking this question. When I have one single Boston training data set, what I can do is I can also use percentage split, where 66, when I say 66%, 66% of it will be automatically taken as a training data set. The remaining 34 will be used as the test data set.
How much to go for test, how much to go?
Yeah. It is never ever advisable to give 50 is wrong. I mean, you can build a model, there's nothing wrong, but it'll definitely be not as helpful. So that is the reason. Let me finish. Accuracy part I was telling you, right? It's not just these parameters that we have to change. We can also change this percentage split. Typically, as a data scientist, what you do is you start with 65%. My team, what when we are building a product, what I will ask my team is change it to 65 35, 70 30, 70 30, 75 25, 80 20, 85 15, 90 10. We stop it there. We can't go to 95. We can go 95 where your accuracy will be very high, but client may cry for you, right at you. So when we go like that, we will see which percentage is giving the best accuracy. Let us say between 70 to 75, or maybe 7 till 70 accuracy has gone up. From 65 you tried, let me say 80 for you to understand. Did you all understand? Even the online guys, are you understanding? Okay, I think they're understanding. So from 65 I'm increasing to 80. Till 80 the accuracy has gone up. 85 also has gone up, but from 8, when it came to 90, accuracy has gone down. So what you do is, then we go to that particular segment, 86 and 14, and then 87 and 13. There we go and pinpoint that percentage that percentage split where it is more accurate. Yeah. And that is the reason I was saying my accuracy in the pharma product was from 87 to 88. 87 to 88 is
It was 87.2, 87.3, and whatever. We don't have a finance data set. If you have a data set, do you have a sales? Good. We can talk about it. Yeah. I have something called direct marketing. We'll just spend 5 more minutes. Is that okay? Yeah. Okay. It is not rows, it is percentage. Now we have 507 rows, right? What is 66% of 501? 507. It is. So it is 334.62. So 335 rows automatically get into train data set, and the remaining data set, remaining rows get into test data set. It works like this, like the way you did it, right? You have loaded the train data set initially, and then you said supply test data set, where you said you have two different data sets. Instead, what you're doing is cross validation. You understood, right? I'm just giving like Boston.csv I give, and then I says percentage split. I just give percentage split, and then I get an output here. No, I don't do it manually. And you can change the percentage. You can cross verify. You can just go back and see which is giving the best. Objective is to be more precise. More precise. Your product should be more precise. Your model. Yeah. Yeah. The objective is that the main objective. But again, it cannot be like he was saying. If you have 507 rows, why don't you do 507 cross validation? That's a very valid question. Where your mean absolute error will be 0. There will not be error, and you will be happy. But when the client is giving you, it will go wrong.
When I went to 90%, so I am getting the data is not absolutely matching. Absolute error is not proper.
Okay, your error is going down.
Yeah, error is going.
No, error is going up.
Yeah.
85 is up. It is low.
85. From 85 to 90, then I'll go one on one.
Yeah.
So 85, 86, 87. So I'll just see at what point of time it is going up, and then I'll decide. That's the point where
Probably you are getting 86, you are getting a better percentage than 87. If you have patience, you can go 86.1, 86.2, that way.
Okay, when we are the client needs exactly where that.
Yeah, no client wants it because client is illiterate about AML generally. That is the big. Yeah, sure, I'm happy. No, her question is done. Yeah. You want a cross file? Yeah, no issue. No issue. Don't hesitate at all. Okay.
In cross validation, which file will it take? Now I have like 3 files right now.
You don't have 3 files. You have, there are 3 different exercises you have done. For every exercise, you have taken a different file. So that if this third step you're doing will not worry about the fourth step.
Okay, fourth. Okay.
Yeah. So now coming back to cross validation, if you are interested in cross validation, please stay on for 5-10 minutes. Otherwise, you can go for lunch in case you are interested. Okay. No, they are keen. Okay. No. Yeah, this doesn't take much time. Okay. Yeah, good. So cross validation. How many rows do we have? 507 rows. In this case, because the first row is a header, let's ignore that. So what we do? I'm opening a calculator. 507 divided by 10. I know I need not open a calculator, but it is something like 50.7. So what it does is it takes an approximation. It takes 51 rows for maybe 8 splits, and the remaining rows it will split equally. It does it smartly. These 507 rows have to be split into 10 splits. Yeah. it cannot do it equally just because the number of rows is like that. So what it does, it tries to do it very optimally. 50.7 is nothing. I mean, at some in some split it has to be 50 rows, in some splits it has to be 51. It very smartly decides on its own. So now again the split need not be the same. One second. Yeah. Now let us say 50. This is 50 rows. This will be set aside for testing. Now from the 52nd row will be considered as training, and a model is built and tested. After that, it takes from the 52nd row till here, all these rows it will consider, it'll exclude them. It will consider them as a testing, and the remaining rows will be used for training. This will be repeated for all the splits, and the average of it is taken for the error calculation. Yeah, 507 minus multiple times, yes, 10 times. Yeah, no, even otherwise, even when you're running, see the sample, that data set that we've taken is 507, but when we've taken, as I said, 800, there are million rows, not thousands, it will be in millions also. The pharma data set we were talking, it was, I don't remember, I think it was 2 million, I think. Yeah. Yeah. So what it does, it takes hours to get. That is the reason, but cross validation model is built only once, right? Doesn't matter. If it is effective, it is fine. Only thing, we should not overfit it. The one that you are showing, that is called over. Please remember the terminology overfitting. Overfitting is where the accuracy of the model is very high and it works well with the data set with which you have trained. That is called overfitting. This could be an objective question or an interview question that pops up. Do you think it is better to overfit, or is it okay even if your accuracy is 99%? They'll ask you. That's called overfitting. Always avoidable. Any other questions you have? Base of data. Not lower accuracy, process and create a model. Don't worry about lower accuracy. Lower accuracy, question of lower is only cross validation. Don't think that if you load training data set and test data set separately, accuracy will be different. No, not at all. It is different modes of. It is same technically, otherwise also. We can only lower it when you actually change the attributes and change the percentage split. Yeah, there are different modes of loading the data set. You should decide. I'm okay. Yeah, online. Let's take a break. What is the time now? Yeah, yeah, 1:10. So yeah, so shall we meet at 2:10? Yeah, let's meet at 2:10.
issue is that the market came from a beach.
Thank you, sir. Because you are, I don't think it's needed. Sai sir, you have signed.
We should. Let's start. People will keep joining. Or what do you say?
Yeah.
Are you all ready for the session?
All your friends also.
All our events. Guys, process. Orientation change. Since you are investing time, so might as well try. Don't do it half-hearted.
How many other students are there? Is everybody left?
So I think that's it. Yeah, we should start. I think with that. This okay. Okay.
Hello. Hello. All of you online, can you just oh,
Yes.
you can't hear me, is it?
Now we can hear you.
It's clear.
How about you guys online? Can you hear me?
Yes, ma'am. Yes, ma'am.
Great. So shall we start the session? Are you all active?
Yes,
Okay.
ma'am.
So what do we do on Veka? Just to reiterate what we have done. What is Veka? It's a tool that helps us create models in machine learning, right? Right. What do? At first you load the file and then you select the algorithm. You also select what is the target variable when you're doing a linear regression, right? And then press start. But my screen, yeah. So we have done a linear regression algorithm and we have actually applied the algorithm on the input data set and created a model. What is the other type of supervised learning we have learned? I'll be asking you more questions in the afternoon just because you're more sleepy. Okay.
Classification.
Classification. What is classification? Yeah, basically you are dividing the group of data set, the group of rows in a data set into different divisions based on the value of one of the attributes. It is based on the value of one of the attributes. That is classification. In clustering 2, you divide the data set into different groups, but it is only based on the pattern, not on the value of anything. Now, one
typical example is of classification is where we divide this classroom into two groups based on probably gender or maybe the experience or maybe the shirt color, let's say, just to give you an example. Now, based on your performance, if the class is divided, can you tell me what is the performance? You may not be able to tell, but your prof who is deciding the performance, he will look into different attributes, which you don't know, right? That is called clustering. Clustering, unsupervised learning. Now, please remember in classification, the target variable. What was the target variable in the regression example that we did in the morning? MV, right? You've selected MV as a target variable. That is, what type of variable is that? Continuous. Continuous is numeric attribute. But in the case of classification, the target variable is a discrete variable. Discrete is which has only specific values. Excuse me, can you understand what I said? Did you understand what I said? Please pay attention to class. Very good. Yeah. So when I said if you divide the group based on the color of the shirt, you only have some particular colors, right? We are not looking at the shades, red, blue, green, orange, some colors. When I'm saying divide it based on the gender, you have two genders. Based on the age group, above 40, above 60, whatever. I'm just giving above 40, less than 40, let's say. Two different age groups. That is called, what is that? Classification, right? If I just say divide the group based on the performance, all the attributes and the data is considered and the pattern in the data is considered to divide it into groups. That is called clustering. Now let us, in the case of classification, please remember we are dividing it based on the value of the target variable, right? So that should be a discrete attribute. It cannot be a numeric attribute. In numeric, you know, right? What values can be indefinite, right? In gender, how many values? Only two. Greater than 40 or less than 40, what is that? How many? Two, right? Are you all getting me? Or do you all understand what I said? No, is it? Did you get it? Okay, great. So when you have an attribute which is numeric, what you do is you convert it into discrete. So please open your Weka file, go to binary.csv. Yeah, pre-process, go to open file. Online, all of you, please open binary.csv. Yeah. Don't you have binary.csv? Did you not download it? No, it was there in the morning also. Please download it. Only after you download, I can explain it to you because it's a little different. All of you, please download binary.csv. Morning itself, I was asking you to download all the CSV files just because of this. No, on the drive, morning I shared a link. Right? There you have downloaded binary.csv. Okay. Now we are explaining classification on Weka. It is there, binary.csv is there.
No, we have only binary.arf.
Yeah, online, do you have binary.csv?
No, professor. In the link that
Okay,
you
I'm just
shared,
I'm giving you on the chat. Okay, WhatsApp or maybe on this window, I'm sharing it with you. Binary.csv, I've sent it on the. Oh, okay, good. Anywhere, either WhatsApp or in this Zoom meet, please download the CSV file. That's easier for you. Yeah, just take binary. Binary missing. Binary missing. Let's see later if time permits. Because we already started a little late, and I see that we are winding it by 4:30. We only have 2 hours, right? A little more than 2 hours.
We have 2 more days left.
Then you have to learn many more things. You will create a chatbot of your own. You want to create a chatbot of your own without any programming. Then you want to finish. You have to pay attention. Let's not take a break in the afternoon. Is that okay?
Yes, fine.
We'll see, ma'am.
Yeah, I know. Yeah, let's do that. But what I say is binary.csv. All of you have downloaded binary.csv?
Yeah, ma'am.
Yeah. Go to Weka, open file. I'm selecting binary.csv. I'm opening it. Can you see there are only 4 attributes: admit, GRE, GPA, and rank. Yeah. Here, based on the score you get in, not you, but the participants get in GRE, GPA, and the rank, the person is admitted in some university. Now, the goal of this project is to build a product which will predict if a student can get admitted or not just by the value of GRE, GPA, and rank. Now, can you tell me what is the target variable you are expecting here? Admission or not? Yeah. So what are the possible values? Is it a discrete value, right? Yes or no? Is it a discrete value or a continuous value? Discrete value. Can you? It is there here on my system. What is minimum? When do you get minimum, maximum, standard deviation, and mean? No. But the point is, we see the values minimum, maximum, mean, and standard deviation when the type of variable is a numeric variable. We are saying that it has to be a discrete variable, right? 0 or 1. Did you all get it? What do I do? Yeah, participants, one of you is not muted. And I think Nagendran, yeah. I have muted him. Yeah.
Sorry.
Yeah, Anup has a query. If they have a query and they wanted to ask, that's a different thing. Yeah, okay. So you understood, right? Now, if you go to admit, you see minimum value, maximum value. You also see type is numeric. Can you see it on the right where my arrow is? Type is numeric. But what is that? The prerequisite we have. When we are applying classification, the output should be a discrete variable. So for that, what we do is we go to filter. Do you see? I have already chosen discrete over here, but go to filter, select the choose button, come down to unsupervised, and in attribute. Please check my arrow on the screen. That will be easier for you. Do you see my arrow moving? Select the choose button there. In unsupervised, you have attribute. In that, there is something called discretize. All of you, my screen is still open. Please do that. Only once you say you have done it, we'll go to the next step. Even the guys who are online, please, I need a confirmation from you.
Done, ma'am.
Okay, perfect. Yeah. So you are selecting discretized, close it, and then you see in choose. You know, because they have segregated it like that. Weka has segregated. There are many more functions. They have segregated for various reasons. Now discretize is there. After that, please select apply. There is an apply button. Please see the screen. My arrow is moving there. Online guys, you also, right? Apply is there. Just select apply. And now, if you can see, the type has been changed to nominal. Initially, it was numeric. Now it is nominal, right? The values have not changed. It's still 0 and 1. But now it is changed to discretized. That is, the values are discretized values. Now, the data is clear. What did we say? We need to do data processing. right? This is part of data processing. Are you all there? Right?
Professor, this is applicable only to the admit attribute or to all. I see it
See,
applied to all admit
no,
GRE
no,
and
don't do
GRE.
that. You have to select admit attribute. I had selected admit attribute. If you have a recorded version, you can just go back and see. I selected admit attribute. I chose discretize and said apply. Now, if you can come down to GRE attribute, you can see the type is even this is converted to nominal. Yes. Have you seen the rank? It is still numeric, right?
Rank is still numeric, so that is why I had this doubt whether
No worry.
it chooses what to discretize itself or we have to select it.
No, we have to choose. Admit is something which we have to choose, right?
Okay.
Now we have selected that. Go to classify. Now I'm choosing. Can I choose logistic? I have to choose logistic. By the way, classification algorithms are different from regression algorithms. I'm only teaching you the basic regression algorithm, which is linear regression. Yeah, they have discretized. Yeah. Rank is numeric. We don't need it, right? We only need the admit button. Actually, because our project is requiring, we need it. Otherwise, even that can be normal, right? So we are only worried about those attributes which we want to convert. Now, this is part of the pre-processing. Now we go to classify. Now I'm rank, the attribute name is there, right? I'm selecting that as admit because that is what we need to predict. And I'm choosing logistic. Here, please remember you can go of any of these options. I'm not going for supply data test set because I have not split this data into two different data sets. I'm just going for percentage split. I only have one data set where I'm splitting it into 66 and 34. And then
so we are not getting the logistic classifier.
you have the functions. My screen is open. Please have a look.
Logic seems to be disabled.
No, the reason is you probably have not selected this admit. Did you? Output should be a nominal output.
Sorry.
If you submit, if you select rank, definitely this is passive. Logistic is passive because the output it expects is
It's working, Professor.
Did you all do this? Are you all there? Right? Have you selected logistic here? Is it active? Did you get it? So after doing that, here we have selected the attributes and now we'll say start. That is obvious, right? We have learned it in the morning. After doing this, we see that (64.7059) is the accuracy. Because you have selected linear regression, the output is a nominal one. You have to choose logistic regression. Linear was also. Yeah, you got it, right? Yeah, this is the accuracy you're getting. As I said, you can just change the split percentage here in the output. I'll come to change the percentage. 66 is there, right? Make it 80-20 or maybe 80. Just change it.
These are incorrectly classified instances. 60 correctly 64% is accuracy. 35. Now you are asking a question, right? Okay, now change this percentage. You had 60, make it 66, right? 77. This is what is 64.
Higher the percentage, higher the accuracy.
No, it's not like that. That's the reason I said increase it 5% more. Maybe it increases, but go to one level, it falls down. So it fell down, is it? Okay, it fell down. Okay, so now increase it 1% unit by unit, and then you can find out which percentage exactly is giving the better percent. Have you noticed your percentage accuracy has gone up? Now increase by 5 points more, 75. Is it gone up? Has it gone up now? Okay, make it 80 now.
So it's 79 is the highest.
For you. For accuracy is 70. Came down. So what you can do is you can increase 75, 76. Somewhere between 75 and 80, you're getting a better accuracy. Other than that, see, this percentage you understood, right? Percentage split unit. Other than that, you can select, yeah. So these are many attributes of it, right? What is a batch size? Increase the batch size. Batch size is the data is given in terms of it's like a batch, a set of rows. Probably it is
Your voice is low.
so 100, increase it a little more and see, maybe 150, make it 150 and see if it is impacting the accuracy. In that case, change that. All the other attributes you could change in a similar fashion. Did you get it? You got it, all of you? You got it? The thing is, please remember your admit has to be nominal. What I've done, I don't know if you've checked it, but select this admit, which is a numeric attribute, right? Now what you do is you filter it. Unsupervised. Something called discretize. Have you noticed it? Now I'm saying apply. This apply only for perfect. It is now changed to nominal. When I say nominal, yeah. Now go to classify and this logistic. And please remember instead of rank, which is output should be admit. Then you go to here. Have you noticed? Sorry. Have you noticed logistic is active now? Previously it was passive. You wouldn't have noticed. Press you got it. The accuracy what? 64.709. You can increase this percentage split. You mean you can increase and try? Yeah. Did you get it? You want my help? You got it? You need help? Did you get it? Did you get it? Do you need my help? Anyone there who needs my help? You have to do that for you to understand where exactly you're getting better accuracy, because whatever you're doing, it should be best. What I would suggest is increase the percentage by 5 units. So wherever, let's say you are getting better accuracy in 75%, from 70 you've been going up. At 75% you got the best accuracy. At 80 you got less. So what you do is from 75 to 80, increase it by. Yes. Start. Just press the same button. Start. 68. So what you do is previously it was 69. Now it has gone down actually. So what you do is make it 76. No, it increases. No, it depends. I don't know how it is. Now you check it. Has it gone up or down? It is actually gone up, right? From 75 to 76 also it has gone up. Make it 77. See the previous one, what was it? So it has gone down. So for you, 76% is the best accuracy split. If you want to further fine tune, you can select this logistic. Select double click or single click it. Yeah. Different attributes are there, right? Batch sizes, they increase the batch size, debug, not debug, but other attributes. You can change those attributes and check to see if accuracy level goes up or down. No, there is nothing like that. Best accuracy is it is the more nearer to 100 it is, the better it is. But again, as I said, it cannot be 100 also because it will be overfitting the data. No, it can be possible if you train it so well only on this data. Never ever can be 100. It can be 100. Google is a very standard company, right? Your GPS maps, Google Maps, how many times does it show a wrong time? It shows a wrong data also, right? Even Google Translate. Who was the one? You were the one who said, right? His client was very disappointed. So all machine learning algorithms cannot be 100% accurate in most of the cases. It example, one of the example I can probably say is in none of the examples I'm thinking I'm able to say that it's there 100%. Even Alexa, many times it talks rubbish, which I can't. Yes. Yeah, yeah. Speech recognition. Speech recognition, it also uses NLP and it also, of course, it takes the math. So shall we go ahead or any queries here? Yeah.
Start option.
Because let me tell you. Remember in logistic regression, what is it? It's a supervised learning, right? What is it? Is it regression or classification? Classification. The output should be discrete. Now I have to tell you everything from the beginning, I guess. Yeah. I'll just say, or you can take anything. Okay. But the problem is you have to have an output variable which has to be a nominal variable. That is a discrete value. What is the type of the variable here? Discrete. Read it.
Numeric.
What is written here?
Numeric.
What is numeric is different from discrete, right? So what we have to do is we have to convert this variable into discretize. You've done it. But what you have done is you need to do apply also. When you apply, have you seen the type is changed to nominal? Nominal is discrete. Go to classify. Logistic is not yet there. The reason is this target variable you have to select admit. Now select it. Now see if you can see logistic. Is logistic active? Select that logistic. Logistic, choose logistic there. Yeah, the start button there. Got it? Happy? So as in the regression model, even here you have multiple ways, right? You can use training sets, applied test. Instead of splitting, you can have different tests, test set, training set and test set. Let me just finish, I'll come to you. We have cross validation. We also have percentage split.
Starting with 10 data, I know that it is 100% accurate. So I can keep that aside to the splitted test.
Train data.
So I can keep it aside, and then the rest of the data I can use it as a use training set.
repeat the question?
Now I have like 1,000
Points.
in that, yeah, 1,000 lines or line and clues. So that first 10 I know that it is accurate.
Only first 10 you know that it's
Yeah,
accurate.
100% accurate. So I'll keep those 10 aside as cross validation. Cross validation. No, supply test. We have to use it.
See, you're getting confused. Cross validation is not, cross validation is a scenario where the system itself decides what to set as a test data set and what will be used as the train data set.
Okay, then I have to use as supply test data.
No, I don't understand why. Only one thing what I can suggest you is in the 1,000 rows, 10 rows, you're sure that it is 100% correct, right?
So I need to make sure
In any data set which is given, you will consider that all the 100 rows are 100% correct because they're given by the client. So there's no question that 10% of it is correct because they're given by the client. Whatever client gives it to you is valid, right? So you're only using a part of it for testing, to test your own software. When you're testing, you have predicted values and you also have the actual values. So you compare the difference between the actual and predicted to find the error. Actual values are definitely 100%. In all the 1,000 rows which the client has given, all of it is correct. That is the prerequisite we have, right? When a client has given the data, you are not going to worry whether it's rubbish or not, right? I mean, you're not going to worry. Junk in, junk out. If he gives wrong, that is his problem. Yes. So all of you have understood classification, right? Now, once we classified based on the admit, what are the possible values of admit we have? What are the possible values? Whether he is admitted or not admitted, right? Two values, right? So in classification also, we have, can you see the output over here? Correctly classified instances are 88. Incorrectly classified instances are 48. There are some values like kappa statistic and mean absolute error. Mean absolute error is very simple as the previous one, though it is this one. But more importantly, here we have something called confusion matrix. Confusion matrix is, I will explain it to you. If you directly jump in here, it is possible you may not understand. I'll open the PPT. Logistic regression is the most basic classification algorithm. See, when you have predicted, in this case, you have predicted admission, right? There are 4 types of values: true positive, true negative, false positive, and false negative. What is true positive? A person who is actually admitted, the predicted value also says he has been admitted. So it is true positive. A person who was not admitted, the predicted value also says he has not been admitted. That is true negative. It is absolutely same. True positive, true negative have passed. And now false positive is where in reality, the actual value says he is not admitted, but our predicted value says he's admitted. So it is false positive. It is falsely predicting that it is positive. And the other option is false negative. In reality, he is admitted, but our predicted value says he is not admitted. So it is false negative. So from this, false positive and false negative are the ones which have failed, right? Now, if we have to take the percentage error, it is false positive plus false negative divided by percentage. Total is true positive plus true negative plus false positive plus false negative. Did you all get it? Right? This is very important. Yes. So confusion matrix that way plays a very important role. Especially this is true when you have only 2 categorical output. In the example that we discussed of admitted or not, it is only 2, right? False positive, mean admitted or not admitted. there are plenty of classification methods. I'm only showing logistic because it is easier and simpler, because we have naive-based classification that is very popular. Random forest also has both classification and regression method. That is a very standard algorithm. Yeah. I got it. You are saying more than 2 discrete values in that. We can't use logistic. Though Veka has the facility, not multinomial logic. You know what? Logistic also, initially when they started, they said logistic, as you know, right? Logical values, Boolean, yes or no. That way they have started. But I have personally coded logistic regression where the values were 4 categorical output. The reason I couldn't say yes in front of you is because you will go and Google it. Google says logistic, the output variable should be only 2. 89% or maybe 90%. I haven't come across, at least I did, the limited time I had spent on Googling. I said, right, random forest can be used, naive-based can be used, K-NN classification can be used. There are multiple classification algorithms. But you all have tried changing the percentage to find accuracy, right? In reality, we don't limit to only one algorithm. We'll apply multiple algorithms based on the output. We'll apply multiple algorithms, and when we go with the random forest is an algorithm which has multiple trees also. So number of trees, like you select logistic and you have an output, right, where you change the attributes. In the same case, when you're applying random forest, you select it, you can, there is something called trees that will be formed. Trees is a data structure. Like example, I'll talk about trees a little later. Let me finish this. If you change the number of trees, as we increase the number of trees, like in the case of our split, what is that split we said? Yes. So as we change, there also percentage changes. So it is not the algorithm alone, it's also the attribute and also the percentage split of the data set. Cross-validation, if you go to cross-validation, we can have more number of splits. We just tried 10 splits, right? In the cross, make it 20 splits. The accuracy will go up. You are asking the question, I can make it 632 splits. The accuracy will be very high, but you should be careful. Yeah. Okay. So again, as you said, there are multiple algorithms. We have to go with that algorithm which suits the best. In all the finance domains, one of you was asking me, finance domains. What we do is we go with the random forest. Random forest regression. In random forest, we have regression and classifier methods. We go with the random forest regression. And in reality, when you're actually applying a project, I use an ensemble of algorithms. When I'm trying to tell you all these things, please don't get terrified. You are all not going to become data scientists, right? You're all on the marketing and sales domain. Interest. Okay, fine. That's good. If you're not getting scared, I'm okay. I can tell you. So in reality, when we are applying algorithms, it is not with one single algorithm we'll stop. We'll try all these things like this, but it will be an ensemble. The first stage will probably apply a classifier, and then we'll go with a clustering, like yesterday's server said. After that, it is possible that we may go with a regression. So there are multiple methods that are applied. Even random forest itself is an ensembler. Ensemble is where multiple algorithms can be used. Algorithm or yes. Yeah. The percentage accuracy will be less. Yeah. See, it's like a balance. In any realistic problem, your solution, you want to learn and learn and learn. So will you read it 100 times a book? You'll do night out before writing an exam. You're spending more time, but would do your efficiency be so good in the exam the next day you write the exam? Because there is no balance between your mental state and what you've studied, right? In a similar fashion, AI works like that. It's not like a simple Java programming where you put if loop, if else conditions. it depends on the data set size and the different iterations you do. It also depends on the client requirement, as I was mentioning. Smartness is obvious. We understand that you're very smart. So, yeah.
So usually
All the no, I didn't understand. You are writing, you are doing the project only because you're wanting to satisfy the output. Everything is dependent, right? Whether you do, it is very simple to train test split itself. This is a different way of doing it. See, when we did Boston, all of you online, please listen to what Mrudula, right? Mrudula is asking, she's asking if cross validation, number of cross validation splits that you have, which we put 10, is dependent on the client requirement. Cross validation satisfies the same purpose as the train test, Boston train dataset and Boston test dataset we gave, right? The purpose is the same. The only thing is in cross validation, it is doing internally by itself. That is, it is splitting the dataset. What you're doing is you're only saying 10 splits. When you say 10 splits, 20% goes to testing, 80%, 10% goes to testing, 90% goes to training. And that is repeated 10 times. The process is repeated 10 times. Yes. So any other queries on the? So remember true positive, true negative, false positive, false negative. Also remember confusion matrix. Don't get confused when someone asks you, if you have done machine learning, what is confusion matrix? Very confidently, they'll ask you what is confusion matrix. So you're coming up with a answer saying that confusion matrix is a matrix which actually facilitates us to understand how accurate your classification model is. Which slide are you talking about? This one? This one? Once you write it, I'll show you a confusion matrix also. That will be helpful for you to understand. Can you tell me in some other example on the healthcare where classification, this logistic regression can be applied? Yesterday we've been discussing on that. Yeah, cancerous or non-cancerous. If the person will survive or not survive. Only two options, right? Survive or not survive. And we can predict. Same thing, cancerous or not cancerous. Cancer. Yeah. Cancer, COVID, heart patient. No, yeah, exactly. Yeah. You are asking, sir, what are the different types of classification? Logistic regression, KNN. KNN is K nearest neighbor. Decision tree. Decision tree is where I'll come to the tree structure again. Naive Bayes and SVM. These are the typical classification algorithms. We also have random forest. When we come to decision tree, shall we discuss about the tree, decision tree? We have 1 more hour, 1.5 more hour. So we need to do clustering here. So we can do that, yeah. We will learn about image recognition and you will also create chatbots. That's the main thing. You want to create a chatbot, is it? No, it's not beta.
yeah.
Which classifier output? 1 second, I'll come there. I don't know. You people decide. I'm fine. Anything. No, the reason I was saying is because we started a little late. Yeah, you were asking this part, right?
Yes, after this, what do we need?
You don't need to do anything. This is only for you to understand how accurate your model is. All these metrics is.
How we see the
Yeah. Even the model is not shown in the class. As I said, model is not shown, model is built. You talk to a data scientist, he will not believe that you have seen a model. In the case of regression alone, you are able to see a model. Even in Veka, in classification, you are unable to see the model. It's basically it's a big equation that is built. You have seen, right? Morning you had some attributes. Yeah, as Veka you are not able to, but when you're doing programming in Python or maybe R, you store the model in an attribute value, and that model, on top of that model, again you have methods where you can supply the input attributes. Morning we will learn, right? 13 attributes, 14. So on top of the model, you set there are different functions, and then you say read or functions, and then give the attribute names. The output of that will be a predicted value. Yeah. In Python and R, many other programming languages. This is again, as you are asking, this is a confusion matrix. A, B, C, D, E, F, G, H, I is put it.
confusion matrix will be only available when you are choosing a logistic.
Yes. I will show it you. This. Can you see my screen here? Right? You can all see my screen, even the online guys. You can't. Fine. So predicted says no, whatever, whether it is admit, pass. We are taking the example of admit or not admitted. Predicted says no, actual is also no. So what is this? 50? True, negative. Perfect. True, negative. Predicted says yes, actual says no. What is it? False positive. And predicted says no, actual is yes. False negative. False negative. False negative. Predicted is no, right? False negative. And 100. Actual is yes. True positive. See, diagonally, this diagonal, the reverse diagonal is true. True. True positive, true negative. And this is false. This is called confusion matrix. Remember, please look at this particular matrix multiple times so that you will remember what is a confusion matrix. No. We have to, numerator will be false positive plus false negative divided by the total number of data points. The total number of data points are nothing but all four. Denominator. 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 Right? Percentage. Total count. Numerator. Yeah. Total number of inputs is nothing but sum of all the four. So remember, please look at my arrow. This diagonal will be false negative, true negative plus true positive. And the other diagonal is where your errors are. That is the count that we have to take into numerator. So this plus this divided by sum of all the four is the error we have. you have already compared and then realized that it is wrongly predicted, right? How are you saying that it is wrongly predicted? Because you already know the answers. In the 20 rows, let's say 100 rows are there. 20 is the test data set, 80 is the training data set. In the test data set, you already have the original values. And now after applying the software, that is the predicted model that you've built, you have got a new predicted values. You will compare the predicted values with the actual values. And only then you say that you predicted, yes, he will be admitted. But when you see actually, this person was not admitted. So it is wrong. But how is it wrong? Predicted yes and actual no. It is not the other way around where actual is yes and predicted is no. There's a difference, right? Where you predicted is and the actual is no. So that is called false positive. False negative is different from false negative. False positive, though both are negative. So you all got it, right? What is confusion matrix? You need not answer me, but at least you got it, right? Okay. Now let's go to, there is another method called decision tree. Decision tree is where the data is split into a tree-like structure where all the nodes, they are related some way or the other. The data may not be related, but the nodes could be related. So for me to explain it to you, we will take your college as an example. All of you are MBA, right? There is an engineering section also in your university, I guess, right? There is a medical section also in your university. Now, in your university educational courses, I'm just dividing it to 3 different groups: management, engineering, and medical. In management, you have regular MBA, you have executive MBA. Now, in executive MBA, I don't know, I'm just giving you some, there is an executive MBA, which is evening batch, and the other one is a weekend batch. Now, I talk to Mrudula, and she says, yeah, I am in the evening batch at DSU. So I know she is in the evening batch at DSU in management. So I can easily map her to this particular location because she gave her characteristics and I can map her here. Did you all get it? Yes. Got it easily. And not just that, she said she is an MBA evening batch. So I can put her in this block. Now, what is your name? You both are in the same batch? Okay. Now I meet Deba also. He also says, I am also in the evening batch, executive MBA DSU. Then immediately my mind strikes. These both are in the same cluster, same node. Yes, basket. Segmenting, clustering. You can't call it clustering actually because you're dividing it based on the value. But clustering is only based on the patterns. Yeah, basketing, classifying, you can call it. I'm just showing you a simple decision tree. That is nothing but a decision tree. I was trying to tell you the same thing, right? Organization. I didn't want to talk about dean and because I don't know how many, whatever is the structure you have. But if I'm teaching a corporate structure, I would definitely have gone to your company and then the HR division, so many divisions, VPs. Even that is a decision tree. Even that is a decision tree. Yes or no? If let us say you belong to what is your job? You're into HR. So are you into HR? Are you into development? No. So that will go to a different stream. In the not development stream also there are many streams, right? Finance, HR, and yeah, like that. You have SR in a similar fashion. Decision is this. Every point there is a decision made, and based on the decision, you will be put into a different bucket or node. Node is a word we use. So these are the way decision trees. The reason I was talking to you about decision tree is
Random forest is an algorithm. Random forest is very popular. Please remember the word random forest. Random forest algorithm can be used for decision trees, for classification as well as regression. But you have a random forest regression algorithm differently. You have a random forest classification algorithm differently. In the case of random forest, you have the number of trees I was mentioning, right? And regression. Yeah. Right. In logistic, you have the values like this here, right? Maximum iterations -1 is there here. I can change the iterations. In a similar fashion, there are many values here. Batch size, I can change the batch size. In the case of regression, random forest, whether it's a regression or classify, you can change the number of trees. That those trees are nothing but based on the data, automatically decision trees like these are formed. And the conglomeration of those decision tree will decide where the value, what the value of our target variable is when you're predicting it. That is the reason random forest turns would be very accurate. You're asking me, right, sir? Alok, sir. Yeah, you're asking me about Niramai. What is the machine learning algorithm? They use random forest algorithm. Guys, have you heard of Niramai, which is very popular, FDA approved AI software? It's my friends, and they use simple supervised learning algorithms. Cancer, it's an FDA approved. Nowhere in the world, in India at least, FDA approval has come for the first time. That too has happened recently. They can do breast cancer. Their software can do breast cancer detection when the tumor is in the very early stage. No doctor can predict it. Accurate. Yes, yes. Paper to chodo. It's very, very popular. FDA has approved. You can see many places. Also. Yeah.
So now in this random forest, usually sort based on that you fall it in that particular category or no. So then it will move into different categories.
Anywhere, wherever it is, decision trees are formed like this only. See, when you take a data, my screen is visible, right? Now I'm showing Boston.csv. Instead of Boston, where the attributes are not very clear, I'll take direct marketing. We'll come to direct marketing again. But direct marketing is where you have age, gender, you own a house or you married, location. Now I'll say I'll only take age. Based on the age, I see that what is age? There are 3 different attributes. When it is middle, I've started with the attribute middle. And when I go to middle, I see that there are 2 different types of gender. Female I go to. And in the female also I have own, rent. I'll say own. I have many things, right? Single, married. Again, when I go, it can, every node I have it by diversification. Like I can split it into different groups. This way you can create decision tree every place. Again, decision tree algorithm is a different algorithm is also there where it will create an optimal tree with less number of branches. Let us not dig deep into it. It will be very confusing to people. I just wanted you to know what is a decision tree. Okay. Yeah. So all of you there, huh? What shall we do now? Okay. Shall we go to unsupervised learning, or shall we try either linear regression or classification on a different data set? Shall we do that? Yes. So do you have direct marketing with you? Direct marketing CSV file? You have it, right? All of you. If you don't have, please download it. No, why do you jump? Let's go to direct marketing because there are multiple ways we want. Only one CSV file. What do you want to convert into discrete here? All of you who are in online, please go to directmarketing.csv file. What we are going to do is we are just going to see what we can do using direct marketing CSV. Open file. Please don't jump doing anything. I want you to be a little patient, maybe a minute's time. Yeah. Now we see 1000 instances, that is 1000 rows and 10 attributes. Let's apply linear regression on this. No. Well, please don't hurry up, sir. What is the prerequisite when we apply linear regression? All regression algorithms are supervised. Numeric, not just the dependent, even the independent variables have to be numeric. Yes. Now, yeah. So what from this data, what I thought applicable would be, we'll just take the salary and the amount spent. In absolute terms, we have to check the box. And I want to remove, the reason I'm showing this is for you to understand that there is a way even in Veka tool where we can remove the attributes that we do not need. So I don't want age, I don't want gender, I even don't want to own home. I'm just looking at the salary and the amount spent. I have selected the attributes which I'm not interested. I'm clicking remove selected attributes. So do you see that? No, married also I'll remove. Mistake. Two attributes. Down. Yeah. I'm showing these two attributes, but you can try any of it. Yeah, great. So these are only removing it temporarily on your Veka tool. Yeah. Now, what we'll do is we'll go to classify. What I'm trying to predict is the amount spent, or maybe I can do the other way around also, right? I can predict the salary based on the amount spent. But in this case, I'm doing amount spent, you do the vice versa. So, now choose linear regression. Are you all getting it? You can give whatever, I don't have any objection. Even your client will not. Because you have not chosen linear regression. You have an error? We'll get it. Supervised, right? No. You have to go to classify. See there, you're trying to filter. This is your drawing. Classify you have to go to. And now go to, no, choose. Percentage split and all is okay. But the problem is you have to decide this function. Linear regression. And now you want to change attributes here, you can do that. Anything. Now percentage, your cross validation you've chosen, let's say, or maybe percentage, whatever, cross validation. Just start. One, you do more than you will understand it. Because it's a tool. Yeah, one of you had an idea. Someone was calling me. Yeah. Yes, enough. Okay. Got it? Salary and marriage. Okay. But the thing is, salary should be predicted. Show me the laptop. Are you able to, did you get it? I'll tell you what it is. The problem here is when you say marriage, it is a nominal value, right? Now, internally, what it does it is putting in an equation, right? What is it doing?
into marriage. Marriage is converted into numeric value. It understands whether what numeric value has to be given. But don't you think it is wrong to give some numeric value? Let's say we say married people will be getting number 1 and unmarried people will be getting number 2. Don't you think it is a biased way of doing it? For us, married and unmarried both are same, right? That is the reason we try to minimize not to use the nominal values in the algorithms. But sometimes it is mandatory, we have to use it. Then we'll get adjusted like this. Right? This is the way to do that. Yeah. It's right. Yeah, we can. See, instead of what you did is you did a percentage split, right? You can also do cross validation. 10, 11, whatever. You can change this. Yeah. So this is y equal to mx plus c. You have a plus c, right? That is the coefficient. You have a linear regression graph.
0.022 is the value. This is a model, right?
This is a model. It's a weight 0.00, 0.00.
Is the weightage of the salary.
And this is the, it is hitting somewhere in the back.
Minus 15 is a value, right?
Yeah, it is an intercept on the y-axis.
Into 0.022. So it comes to, let's say,
Take 1000, no? That will be easier.
1000 into
22 minus 15. So 4.6968. 4.682. Will be 22.
7. Amount spent is 7. So for 1,000 rupees, we are spending 7 rupees.
Yeah, same similar value. Yeah. Something like that. You have to see. Salary cannot be 100 rupees. No, because see, salary and amount spent are definitely not directly proportional, right? A guy who earns crores may not spend. Yeah. In this case, to keep it simple, I have shown this example. There are many attributes. Earning more. It also has that he is earning money, but he has more responsibility. You have a married attribute, right? See, all of you, I have shown you an example only with the amount spent and the salary, right? Back there, one of them has taken the salary and married. Okay, married is what type of variable is it? Categorical variable. But I was saying when Alok sir was asking, even I said even the input variable should not be categorical. But the thing is, Veka tool makes it such that the input variables will be automatically converted into numeric variables. The reason I didn't want to touch into that was because it is erroneous, but they have done it. So I want to focus on that point so that everyone, some of them have done it. Yeah? That's good, you have done it. So basically the reason we don't like to convert categorical variables to numeric variables is now when they did it, married people have got one numeric value. Unmarried people have got some other numeric value. Let us say married was given number 2, unmarried was given 4. Don't you think the system is biased for unmarried people giving more value, right? 1 and 0, if let's say married are 1 and unmarried is 0. So married people are getting more biased, right? That is the reason we don't go, we don't actually prefer converting categorical variables into numeric variables. But when the algorithm forces you and the client also forces you to use that attribute, we have to go for it. That is the thing. Yeah. Okay. So we did linear regression on a different attribute, right? Shall we do classification on the same data set and then take a break if you're keen? Otherwise, I'm ready to continue. Yeah. You want 5-minute break? Yeah, well, I don't have any issue as long as you're okay with it. So let us go with the logistic regression here itself. You will choose logic, but what is the output variable here? What is the type of output variable you need to have? Yeah. There is no logistic because the amount spent is the target variable you have chosen. Choose a variable which is And take it, load the data set again. You have deleted all the files, right? You please load the data set again. Direct marketing. Huh. Maybe age. I don't know. You choose. That is at your freedom. I want you to do it so that it will be helpful. You wish. I want to have an understanding between own home and salary. Let us see. I want to do that. Just that. You take attribute as the own home. Yeah. So why will you take linear? Own home is whether you're owning a home or not. So it is the classifier, right? I mean discrete variable. Now you choose logistic. Choose logistic. No, why are you going here? See what you have to do is go to classify. This is say own home and this one is the right. Go to classify when you're applying the algorithm. Linear is there. So what you have to do, you have to take it to own home, right? When you're doing this one, now you go to choose. See, logistic is active now. Say start. Yeah. No, please remember, I think we are getting confused in the pre-process method. Pre-process is only for the attributes. When we are selecting the algorithm, please come to classify. Yeah. You go back here, select somewhere else, go back. Yeah, this should be the output. Salary is a numeric output, right? We have to select own home because it is a logistic result. Now go to choose. Logistic is out. Yeah. Up, start. Yeah. Yeah. It's easier for me. Yeah. You've already done it, is it? Yeah. Yeah, logistic is passive just because whenever it has to be go here, it checks for this target variable. Target is a numeric here. Please check the target variable to, you have to change the target variable to own home. Yeah. Now go to choose. You'll get, yeah. Because the choose is linear regression. You have to choose logistic. You get it? Yeah, perfect. You got it. No, you got the output also. Conclusion is 1 second, sir. I'll come. See, own rent. You're owning a house. You're renting a house. This the original values. This is the predictable. This is confusion matrix. I told you, right? False positive, false negative. So this is true positive. These two are true positives. These are true negatives. No. What we are saying is own home. So please, no, go to again open file. Yeah, open file. You need to process it again because then now own home and more spend. Other no. Don't do that. Go there. Select all others other than these and then say remove. You have to remove it. No? Remove. Now go to and please select this amount spent should not be there because it's a new own home. Own home. Oh, yeah, perfect. See, this the correctly classified. Right? 87 plus 125 is 212. These are the wrongly classified. Mm. This model in logistic regression will not is an equation, complex equation, but that will not be shown even in Veka. In linear,
was showing in this.
yeah, only in regression. So all of you, can you see the confusion matrix over here? Right? This is very helpful for you to understand. I was showing you it to you on a Google, right? How the confusion. This is what is confusion matrix. So A, B over here. A, B is own the house, rent the house. This the here it says it is predicted as owned. It is predicted as rented, and horizontally it is actual rented, actual owned, and actual rented. Horizontally is the actual values. On top, vertically is the predicted values. So if you go the reverse diagonal, they are the true positive and true negative. And the diagonal values are false positive and false positive. True negative is okay. Yeah. 67 and 38 are wrong. So 67 plus 38 divided by the total count. Or you can say 109 plus 67 plus 38 plus 126. That will give you the accuracy. Yeah. Got it? So shall we take a 5-minute?
Ma'am, can you please click on preprocessor?
Hello. Okay. Good. Good. You told me, but we have finished the clustering. But I'll repeat it. All the online guys couldn't hear me, but now at least are you able to hear me? Anup, can you hear me, Anup? I want an answer. Okay. Great. All others online, can you hear me? Perfect. Yeah. So we discussed about the classification. We discussed about the classification before we went for the break. And now after coming from the break, we did a simple exercise on the clustering. Okay. I did not know you were not able to hear me. So we did it, but we'll repeat it. In the meanwhile, if there are any queries, because we are waiting for others also to join, let's wait for a couple of minutes. I'll come back to you. Any queries there?
Ma'am, how to select that target variable as a binary in that previous file? Because all the variables are coming numeric.
No, no. What is the question you have in classification? Is it
Classification, that
okay?
binary.
Uh-huh.
So there actually target variable I am selecting now, it is coming as a numeric.
Uh, why don't you share your screen and ask me?
Okay.
I'm stopping my share. You can share the screen.
Yeah.
Nandakumar was asking, is it?
Yeah, actually sharing is disabled. Sharing is disabled, ma'am.
Yeah, sharing is disabled for you, is it?
Yeah. Yeah, ma'am. What I was asking simple question is that when we have the 4 variable, right? Admit, like binary, we have given a CSV file, right?
Yeah.
So there was some GRE, GPA rank
Hey,
was
can you
there.
please be a little silent? I'm unable to follow him. And Nandakumar, a little louder, please.
Okay. Yeah, ma'am. No, I was referring there is a one file called binary.
Yeah.
So there we have the variable called like admit, GRE, GPA rank. So I
Yeah.
was trying to get that do the logistic regression where the admit we can do the 1-0. I can see that. But when I'm going put the classifier, right? So there actually how automatically that will they will take as a admit they will take as a 1 and 0, right? So we don't have to convert that, right?
Yeah. So what we do is in the pre-process, you remember we said there are different steps in model creation or data science. We have data understanding, data pre-processing. So pre-processing is related to the data. So what we do is here, we are converting the admit into discretized. When we say discretized, it's a numeric value, right? 0, 1. It will still be 0, 1, but you will convert into a new nominal value. Nominal is basically discretized. So you have a function, go to choose in unsupervised attribute. There is a method called discretized.
Okay.
Yeah. Select that and say apply. When you do apply, it has to convert into nominal. Okay. Because you have to select and then got it.
Okay. Okay, ma'am. Okay, thank you, ma'am.
So guys, we just started clustering. So even the online people somehow couldn't hear me previously. Yeah. I have put 11 clusters. Okay. So I'll tell you more about it. Okay. Now, even the online guys and the people who have joined just now, can you tell me what is the difference between classification and clustering? Oh, I'm not talking about data process. What is the difference in the process? Yeah, we will predict something. Right. So basically classification, we have labeled data. In clustering, we don't have labeled data. And in classification, because it is, that's the reason it comes under supervised. Guys online, if I'm a little faster, you have to stop me there.
You will use it for prediction. In case of clustering, unsupervised, based on the data pattern of the data, you're deriving insights from the data patterns and using it. But remember, both the places, classification or clustering, you're dividing the data into groups. Classification, you're dividing based on the value of one of the columns. Clustering, you're only dividing based on the data types. Did you all get it? Yeah. Now, I've been giving an example, whether it is a gender-based division, you say it is a classification, right? All of you, I don't know, again, I'll repeat it. Let's say we divide the cities into different cosmopolitan, non-cosmopolitan. What is it? Classification, right? Now, you know what? Even Amazon or any e-commerce site that you work on or that you use, it divides the customers. How do you think it divides? Is it just that? No, is it just that? Yeah, many more. When you say many more, all the attributes and the data pattern is decided. So what is it? It is clustering. So it will segment the customers and it will group them. Excuse me, I need your attention. I'm telling you very, very important stuff. If you have any query, please ask me. If you're not interested, also, I'm happy to hear that. That's okay. No, you didn't miss out. I'm starting it again. Nothing is missed out. All of you, even the online people did not hear it. So we have started again. So the reason I'm talking about clustering is e-commerce. In e-commerce, all the customers are segmented. Segmentation is done using clustering algorithm. It is also done it is only done based on the data pattern. Now, you are from Bangalore. Okay. He is also from Bangalore, probably of similar age. But when you buy something, the suggestion you get will be different from the one who is sitting just next to you. I'm not giving her as an example because probably her buying patterns are different because the gender is different. But a guy who sits just next to you, his buying patterns would be different from yours. Why do you think it is like that? Because it is not just on the age and the location. It also depends on the amount you spend and maybe the likes and dislikes you have. So what is it done? What is it doing? Probably the suggestion you get may be the same as the suggestion someone in California is getting, because you both are probably in the same cluster. It all depends on the buying pattern, not by single variable value, single attribute value. Various patterns. You don't have any. I'll come to your doubt. Let me just finish this. I'll definitely come to you. So based on this, the grouping is done. So it understands when a guy, you remember user-based recommendation yesterday, right? User-based recommendation is done, but how are the users grouped? Users are grouped using segmentation. That is user segmentation, class clustering. So it's an ensemble of algorithms. So you first do this and then you go to a priori algorithm. That is a decision tree. Decision tree is what we discussed some time back. But no, that is not. Clustering is never ever based on the value of anything. It itself is deciding. Internally, it has a mechanism. Yes. When you're specifically mentioning this is this is that, it is never clustering. It is called decision tree when you have a tree based. Yeah. You could. See, it is like this. Clustering is done internally based on a mechanism it understands by the patterns, data patterns. Now, though you have come a little delayed, what I want to share it with you is simple k-means. Here, all simple k-means are there, right? These are all clustering outputs that we have put. Now, in this simple k-means, I have put only two outputs, two cluster out, two divisions. If you see,
Can you see the different attributes over here? 0 has 301 rows. Cluster 0, that is cluster, first cluster. Second cluster has 359. The numbering starts from 0. That's the reason it's 0, 1. Now, if you notice, in the cluster 0, the mode value is young. That is, more young guys are there. In the cluster 1, more middle-aged people are there. That doesn't mean that in the cluster 0, there are no middle-aged and no old people. It's still there. But most prominently, it is young, female young who are rented and who are single and where the location is close. There is no prescribed value that this is the way it is. The average salary is this, the average salary. So there are many, the children is like this, history, not applicable, both the cases. No, in this case, it's not applicable. So it is a combination of the different variables and values. No. See, it is when you say single, that doesn't mean that cluster 0 only has single owner. It is more people, more girls. Yeah. No. It's not like that. Or basically what it says is, it is more. If you open your Excel sheet and see, there are young female who are rented and who are married also. But in this 301 people, maybe 250 people are single. The remaining 51 are married. It is predominant value, mode value. Mode. Not mode, but what is it? Mode value.
When you take an average of children, it comes to 1 point.
Yes, 1 point. Wherever numeric value is there, we take an average. So that is clustering. And now let us open a file. I am opening directmarketing.csv. I go to cluster here instead of classify. There are many clustering algorithms. K-means clustering is very commonly used. And even here we are going to use simple K-means. Let's say start. I've given 10 clusters as the input. I'll explain you how to do that. But all of you must be getting only 2 clusters. All the guys who have joined a little late. Yeah. There is a way where you can change the parameters in any algorithm. What is that? Yeah, choose. You just give 1 click and you see the output. Online guys, can you hear me?
Yeah, ma'am. But here also, why we need to use percentage split?
Your question, can you repeat it?
Why we need to use percentage split here? Should we
don't need to use percentage split. This actually doesn't make much sense. I'm really not sure why these are enabled, but we don't need to use percentage split.
Your voice is slightly low.
Yeah, we don't need to use percentage split. I'm not sure why these are enabled, but what we do is we just use the clustering algorithm and the attributes are selected over here. Okay, and can you see number of clusters I have given 10, and that is the reason I get 10 clusters. By default, it is 2, and you guys would be getting only 2 clusters, right?
Yes, ma'am.
Yeah, there is an attribute called distance function. Do you see that? Euclidean distance and Manhattan distance. These are the distance functions. When clustering is actually made, what it does is it calculates the distance between the different data points. And based on the distance, it groups the items, the data items. Now, when we say distance, how do we measure the distance is a question you may be having, right? Like when I just have 2 attributes and 2 points, X and Y attributes and 2 points. You know the formula how we calculate the distance between 2 points?
Yes,
y2
yes.
minus y1 whole square root, right? Plus x2 minus x1 whole square. I mean, under square root of y2 minus y1 whole square plus x2 minus x1 whole square divided by 2. That is a standard way. But now we have attributes. How many attributes we have? We have 14. How many we have in direct marketing? We have 10 attributes. 10 attributes, right? How is the distance between 10 attributes calculated? When we see now, when let us go back to the, yeah, I want you to pay attention now on me. I mean, on what I'm teaching now more. Let me go back to here. In this example, how we had a discussion, right? The professor was asking me, how do you think we divide it? We divided into not we, but the algorithm divided into two different clusters. And in this cluster, more young women are there. In the second cluster, more middle-aged men were there. In this first cluster, more young women who have rented the house, who are single. All these values are there. Now, as a human being, let us say you know all these details and you have to divide it into 0 and 1. You would also do it, right? Probably in a similar fashion, but you may not be able to specifically discretize or differentiate why exactly you have done, because based on the patterns. And how is that you're doing? Because probably you understood that young women who are rented out and who are single and other values are there, who are close to the location with a salary so and so, and many other attributes, all of them behave in a similar way. And middle-aged men also behave in a same, but there are some other middle-aged men and old-aged men and middle-aged women who are also behave in a similar fashion as the young women. So you'll also put them in the same group because their behavioral attributes, which are digitized over here, are put in this. How do? You're calculating the proximity with your mind alone, right? If you have to do that, there is something called distance measurement in machine learning. These distances are nothing but it calculates how close the data items are there with different attributes. In this case, 10 are there, but in reality, it can be in hundreds of thousands also. And we have Euclidean and Manhattan distance, the distances which are very popular. Manhattan distance, anyone here who has been to Manhattan or heard of Manhattan? You've heard of it? No. Euclidean distance is very similar to our distance measurement. Manhattan is like this. Euclidean distance is like if I have to go there. No, if I have to go there, probably I would have directly gone there. If there is air which has to go from here to there, it'll directly go there, right? But if me as a human being, I have to traverse there, what would I do? I go straight and then take a left perpendicularly because the arrangement of seats here is like that. Even in Manhattan, the arrangement of roads is such that everything is perpendicular, like in the classroom. And this distance measurement also, when you say Manhattan distance, let us say the data points are just go here. Let's say there is a data point here and there is a data point somewhere there. So it will not go directly, but instead it will take the measurement from here to here and then there. So that measurement of data distance is called Manhattan distance. No, we can't take hypotenuse. And in this case, by default, generally we go with the Euclidean distance, but there are other distance measures also. But distance measures, Euclidean and Manhattan are very popular. And some places we have to go with the Manhattan distance. It depends on the domain again, the domain where we are using. Now I would suggest you to go and change this distance measurement from Euclidean to many more are there. Euclidean and Manhattan are very popular. Synopsis is there, attention is there. No, what you can do is I would advise you to change it to Manhattan and try. No, but I don't think or that's okay. Leave it there. That should be okay. There is something called normalize, and I haven't taught you that. I have changed the maximum number of iterations to 900. Come down. Max iteration. Last but one. Number of clusters. No. You can change whatever number you want. I have just changed it to 10. Mhm.
Have changed how to. It's not showing.
I don't know why it is like this in my system. That is system issue. Yes. Yeah. See, at least can you see there are some marks over here. So what you can do is yeah, it changes when you're applying it. Now the first one is open, right? No, for you it's the third one. When I say tab, it is going to open now. Say open now. Okay. You for you the same issue, is it? See, for those of you where it is probably not visible, it is the system setting. So what you do is you go to number of clusters, you in particular. Okay. Now go to tab. When you go to tab, by default, it go to next possible button, that is open. Tab again, it goes to save. Then tab again, it goes to OK. Is this a mouse or that? Okay. Oh, is it Mac? Is it? No, is. Can you minimize it? Can. Where is that? Scroll down. Yeah, exactly. Okay. I got it. No, the problem. Okay, 1 second. You have to. Okay, fine. What? Where is it? Number of wire canopies. Okay. Oh, so you have many more. There are 3. See, if you see that, can you see? After the number of clusters, you had 2 other options, which I guess that next is button. So what I did, tab takes me to open, and then tab, then now you got it. Yeah, run it again. Okay, you have changed some value there. Did you change some value here? And then number of clusters, make it 11 or maybe 20. You make it 20. Only then you'll realize. You'll understand 20. Yeah. Sit. Come down. Tab. No, no, you have to say okay. You have to okay. Yeah, because number of clusters is still 2, right? You have to change that cluster numbers. Change it to maybe some number 9, 10, whatever. Yeah. Okay. Start. Yeah, got it. You just made 2, but what is the difference in the number of right?
This doesn't change.
Yeah.
Some amounts
Yeah. Yeah. There is a difference, right? That's all. You can check this. This
Clustered instance. Oh yeah, this also is slightly changing.
It will change.
45. So this
6
is
points.
yeah, 1000, right? So yeah. This
Manhattan. There are many other distances, but these are more popular. Online, guys, do you have any query? Oh, good. That is good for you, not for me. I mean, even for me. Any query? Got it, huh? Any query? So shall we take a different data set and apply clustering algorithm on top of it? I will stop sharing my screen. I want you to take a different data set. Take your data set, your own data set, some CSV file. Maybe your own CSV file. You also have CSV files on your system, right? Take it and apply clustering algorithm.
Ma'am, can you please explain the difference between Euclidean and Manhattan?
Manhattan distance and Euclidean distance is where the distance measurement mechanism is a little different.
Could you please click on choose?
Yeah, I will tell you. Now, do you see my MS Paint screen?
No, ma'am. I see the Vector Explorer.
Now you see it, right?
Yes, ma'am.
Yeah, okay, great. Manhattan distance, actually, what is the distance between A and B? You can probably say you'll draw a
Three
straight
blocks.
line between A and B, and that will be the distance, right? Yeah.
Oh, yeah.
Yeah. Okay. Now I'll take a different color. Okay. Now for me to draw a line,
The first one on the right, ma'am. Besides the brush.
yeah, perfect. Now, if I have to find the distance between A and B, probably you would say this is the distance, right? But this is the Euclidean distance, but Manhattan distance is not that. You know what it does? It calculates a distance like this. This
Good.
plus this.
You'll have to leave it there and pick it again.
Yeah. Plus this. Plus this.
Got you, ma'am. But in the output, there is no much
Plus
difference. That's the reason I was asking.
Yeah, but there is a difference, right? Now you're only trying with 500 rows and you're expecting a difference.
A difference,
You know,
okay.
yeah. So this is the Manhattan distance. In the output, there is a marginal difference. But let me tell you, this marginal difference also plays a major role when you are actually doing a prediction or machine learning. Let us say someone has cancer. I don't want that to happen, but I'm just telling you. And your prediction algorithm says for 99 people, it has said everything is perfect. But that one person, unlucky person, you came back saying that you don't have cancer just because there is a marginal difference. Or in 1,000 people, 1%, your software did not predict well. Don't you think it matters?
It does, yeah, ma'am.
Right? So that is the reason we always try to improvise our model. Again, we cannot overfit it. As I told you the reasons, there should always be a balance between overfitting and the proper prediction also.
Got it, ma'am. Thank you, ma'am.
And there is no hard and fast rule that you have to go for Manhattan this time and Euclidean this time. You have to try the different options, whichever fits the context, you have to go with it.
Got it, ma'am. Thank you, ma'am.
Any other queries?
No, ma'am. Thank you, ma'am.
The session is open for Q&A now. He's asking about the future, very happy about the futuristic technologies he's learning, and so asking about the future class. That is the class, upcoming class, where you learn making a chatbot. So what you do when you're learning chatbot is we will teach you everything from basic. But again, lots of exercises left to you for creating the chatbot fully. Once you do the chatbot, you can integrate it into your Facebook or maybe, but that is out of scope. We will share you where exactly you will integrate it. We will not, yeah, APIs are there. So we will tell you how exactly you will do it, because your URL link will be produced. You will have URL, you know, right? What is a URL? URL is a link, website address. So your chatbot will have its own website address, or URL is exact. You can, your company should be ready to go for it, because you have to train it well. If it is perfectly good, we'll only teach you how to go ahead, and your chatbot will respond for the questions for which you have trained it. Only for the questions you have. No, let's say you are in the finance domain. Maybe you are in the banking. I don't know. I'm just telling you. Someone comes and asks, what is the balance in my account? Now, I may teach you till an extent. If someone asks you query, you will do it like this. But your chatbot interacting with your bank account has to be handled by you. That is left to the APIs provided by your bank. Let's say you are in an e-commerce company, and there is an end user who wants to interact with you and ask, I have ordered so and so, my order ID is this. What is the status of it? So you have to go to that API which tracks the status of the ordered item. Those backend will be handled by you. But we will tell you, till here we will tell you, The left out part, which your company alone knows, we cannot handle. You can integrate it. Yeah. But you can create a simple chatbot like, what is the capital city of so and so country? Things like this. Those chatbot. Yeah. Yeah. Again, Google API. Yeah. But it will be very interesting because you will see a chatbot which is working for you. Yeah. How many children do I have? You can write it and it will tell you in case you forget it. That also can be done. I'll teach you that part also. Yeah. Yes. No, no, no. Veka, we are done with it. But yeah. Yeah. For those of you who are more keen on knowing about Veka, you have learned about associate rule mining, right? Yesterday, Dr. Srinivas was mentioning that also can be done using a priori algorithm, though that is out of scope because a little more complex and more time taking, which is out of scope. We didn't think it. That also can be done. In case you have interest, you can explore more of it. Yeah, everything. The document is there. Yes, we will get it. So did you all try with your own CSV file? What did you do? You do clustering, is it? Yeah. You have divided into different groups. Okay. Right. Hey, one important thing I wanted to tell you, it is not just these data sets that you work on. So you have many data sets on UCI. Okay, UCI is, yes, it's not just here. You can go to kaggle.com. Kaggle is a very popular online portal where there are competitions which are held across the world. So if you're keen on programming and if you want to participate in the competition, if you participate and win and be in the top 1 lakh, top 10,000, then you'll get a dollar paying salary sitting in India. I mean, yeah, okay. So, and not just that, there are sites called india.gov.in. Please go there. You will see real-time data sets. India.gov.in, gov.in. Okay. Yeah, COVID. Yeah, there are some data sets related to COVID also. It may not actually, I'm not sure. India.gov.in. If you go here, ODG platform. So you get so many data sets. I have done a small project as a voluntary thing where long time back, 6 years back, maybe about what is that? You don't have restrooms in the schools, right? Swachh Bharat initiative. Back then, before even Swachh Bharat initiative was just in the launch phase. So we did a small POC to understand how many schools, government schools, have how many toilets for women, girls, which is more needed. Now data is available here. Data is available, but it was not related to the toilets alone. It was about different places across India. So what we did was we did a clustering algorithm. We applied multiple algorithms, and then we realized that, and it's not just the restroom. We did another thing about the security of women in India. So back this happened that near what is that Delhi incident happened. that happened just, yeah, Nirbhaya incident happened, and immediately after that we did it, and again it was realized that Delhi is the state which is most insecure for women, unsecured for women, but Karnataka was probably in the 9th position. We did not give, it was our own initiative, it is for our understanding. West Bengal, I don't remember, but Hyderabad was a little unsecured than Bangalore. So Bangalore is more protected. Every country has a .gov.in. Okay, even US has it, Singapore has it, there are multiple data sets, but India being a diverse country with multiple problems, any of you who is really keen on solving a social initiative, I mean, being part of a social initiative, you are part of NGO, right? Bengal, related to Bengal also, there could be some data sets, I'm not sure. But yeah, there are data sets related to all states. You can sort them by the Bengal, West Bengal, and you'll get it. Literacy rate also, you have multiple. And there is, for all of you, there is something called HackerRank, hackerrank.in. I want each of you, please go there and participate. It has simple competitions like regression classification. Don't worry. HackerRank. I'll just type it here. It's not hackerrank.in, it is hackerrank.com. I said it wrong. Kaggle.com has a little complex competitions. UCA data set, is it? Okay. Here there are plenty of data sets, right? Annealing. Yeah, you have to register when you want the world to recognize your competition. I mean, if you participate in a competition, you get a good rank. Yeah, all algorithms. And it is not, AI is not used, AI is internally used, but basically this is where competitions, you can compete with people within India, with different people. They need not be from your own college or institution. Public. You'll get it in india.gov.in. Sure, you'll get it in india.gov.in. Pakka sure you'll get it. We have done it on the violence, right? Violence against women. But the only thing is you need good amount of pre-processing, as we were mentioning before. Even you apply the algorithms, clustering, classification, whatever, you need to have a good amount of pre-processing the data. So you have to understand the data. There will be lots of blank values. You need to spend good amount of time. It will not be as fast as we did in the class. It will be months together. Yeah. Properly study it, pre-process it. Veka, I'm not sure if it will be helpful only to do with the Veka. You can try it out. The one option I can suggest you is, even if it is, let's say 1 lakh rows, 1 lakh rows, I don't think is possible with Veka. So what you do is take the 1 lakh rows in your Excel sheet and take only those rows where all the columns are filled. And yeah, in case that also is difficult for you to load on Veka, what you do, you sample the data. Sampling is random sampling. You can take randomly 2,000, 3,000 rows. Right. Okay.
Announce for the upcoming days, basically 23rd, 24th, 2 days, right?
Nothing. You have to get your laptop, and I want you to be a little more interactive because that will be helpful also. Till now, you have only learned. You created models. You don't know. Yeah, you really don't understand what the model does, right? But there, you are creating a chatbot. You'll be happy when you say hi. You share the link with your friend and say you ask about any movie. My chatbot will answer. He will be amazed getting to know that you have created a chatbot like that. Tell me. One day is chatbot, the other day is on the image recognition. We will do something. We will share the link with you, the latest link, because we don't want you to download something and then the link whatever you are getting. Because it must be an Excel sheet. You have to save it as a CSV. You would not have saved it, so open it again. Go to file, save as. Go to CSV MS-DOS. Save it. Yes. Yeah, I will also leave now. That's okay. Thank you. It's good.
Thank you, everyone. Stay safe. Take care.
Because it is as an XRR file. Okay. Is this problem encountered? So there is an issue in your CSV file. This happened. So I would advise you to close your wake-up file because partially it is probably open. That happens. Yeah, try it out. What is your name? Some pages in your worksheet might be lost. Okay. Desktop. Go to desktop. There is some problem with your converter. Okay, even I have faced the same problem. So go for a different CSV file. Even I have MPG file. It was the same issue. You can do that.